Make sense? Make sense? Okay. So, what we have talked so far. So there are two fundamental technologies that have been used in blockchain, and they are, number one, hashing. Do you guys remember that? And what is the second one? Absolutely. So asymmetric encryption. Can anybody explain to me the difference between? Okay, here my question is out. Can anybody explain the difference between encryption and hashing? Who can explain me the difference between encryption and hashing? Did we cover this point? Or did not? Deepak, your team is looking a little low energy. What happened?
It's a late night FIFA match. So guys, come on, let's. I mean, you come and blame me, then let's be active.
So, okay, let me ask you a question. So, which team did you all support yesterday? Argentina. Okay, and how did you find the match? It was like a final, right? The way a final should be. Yeah? Okay. So let's come back to the purpose for which you are here. Okay? So we talked about, the other day we talked about how blockchains are created. And how do you define a blockchain? Chain of blocks. People have understood that. How did, okay, let me ask this question. So, when you call chain of blocks, then how do blocks get formed? Can anybody explain to me? I need people who think they know. How do blocks get formed? Mining in the case of proof of work, right? And in the case of proof of stake, what is that process called? Validation, right? So now let us start from there. We understood the blockchain. The first implementation of blockchain was. The first implementation of blockchain was Bitcoin, right? What is Bitcoin? It's a peer-to-peer transaction enabler, correct? Where two people can send money to each other without any intermediary. That was the key proposition, correct? There are more things happening, we'll not get into those right now. But we also talked about Ethereum, which came around 6 years later, which brought a new dimension to the whole blockchain. Okay, guys, I think you all should be, first of all, you should feel excited about what you are going through. Are you? Yes. And believe me, as I have not forgotten my promise that we will take you to a level where you definitely can work on that and become a solid blockchain developer. We definitely have that in mind. And whatever I am doing right now, these things are very, very important for you to start developing. Right? So Ethereum, what did Ethereum bring? Can you guys tell me? Smart contract. Yeah, who said that? Very good. What is your name? Redis. Praneeth. Okay, very good. So, yeah, you can sit down. So, Ethereum brought a completely new dimension. And Ethereum, what Ethereum said that let us make a platform which makes this solution generic enough. It should go beyond payment. Bitcoin was primarily for payment system, correct? Payment is a very important use case, no denying the fact. But then the whole world does not run only on payments, right? There are so many other things that really need to come for solution to become generic enough, which really comes and starts impacting your life in various ways, and that is what Ethereum did. Now, Ethereum is basically a proof of stake. In fact, when it started with proof of work only. Okay, and you know one of the major problems of proof of work mechanism is what? One of the most important problems for proof of work mechanism is what? Energy consumption. You cannot sustain. And why why does proof of work mechanism need energy? Who can explain to me? Longest blockchain. And how do you get that? You are required to solve a mathematical puzzle. And that puzzle is finding the hash with some leading zeros, depending upon the complexity. Correct? You guys understand this so far? So now what happened? There was a project which came on Ethereum in 2017, which is called CryptoKitties. Have you heard of that? Anybody? Okay, so CryptoKitties is basically a game in which there are so many functions, features. You can go and breed two kitties. If you have not done so, go and look at this project, CryptoKitties. Okay, and this game became very, very famous. This game became very game. And if people are playing game, if people are doing something on the project, then what is happening in the backend? Transactions are getting created. Understand? Those transactions have to go into a block, right? Now, block space, you understand it. How many blocks? How many transactions can get into a block? You understand that, right? Block space. Now, people started fighting for block space. Everybody wants to put their transaction in the block. Now, this created two problems. The first problem was that everybody, and if you have to put your transaction in a block, what do you need to do? Sorry? No. Bidding is, yeah, I mean you can say that, but somebody else said something else. Incentive. Okay. Now there is another concept in Ethereum which is called concept of gas. Okay. Now try to understand in the most simple way as I am explaining to you. There are many underlying complexities here which we will uncover slowly. Okay. But what I am telling you, understand that very, very clearly. So any transaction that you do on Ethereum, for example, you have to spend a transaction fee which is called gas. Okay. Now how is gas calculated? Gas is calculated depending upon how much complex transaction you are conducting. What are you doing? Are you just going and writing small thing, or you are doing some mathematical calculation? See, ultimately, at the end of the day, you have to understand one thing. You are a layer. You are running your program in something which is called a virtual machine, which is called Ethereum Virtual Machine, EVM. Have you heard of EVM? Yeah. So you are running your program, smart contract, what is called, in an EVM environment. Ultimately, underneath is what? The same computation. It's working. Ultimately, it is going and hitting the computer, right? So you are doing some calculation, and depending upon the calculation that you are doing, okay, what is happening that you have to pay a transaction fee. Now that transaction fee gets distributed across several people. Let's not get into that. But the idea here is that you have to pay some transaction fee. So far with me? No. So you have to keep responding to me, otherwise I start losing confidence that you guys are not understanding. So please be more energetic than me. Done? Promise? Okay. So what happened that when CryptoKitties became famous, many people started playing the game. Now what happened? Number of transactions that were trying to get into the block skyrocketed. Now people had to pay huge amount of gas for putting their transaction into the system. Now it became to an extent that hundreds of dollars were required to be paid. $100 means what? $100 convert in rupees, how much? 8,000 rupees. 8,000 rupees, 16,000 rupees, even more to put one transaction. Did it only impact CryptoKitties? Listen to my question carefully. Did this problem only impact CryptoKitties application? No. It impacted anybody. Ultimately, Ethereum is, a chain of blocks. Now, this chain of this block is getting transaction from all the applications, all the dApps like Abhishek mentioned earlier, all the dApps which are running on Ethereum. Any confusion in this? Everybody will put his or her transaction into the block, be it CryptoKitties, be it other game, be it something else. Every transaction has to come in the same block. So now what happened? When this became so expensive, then the whole world shook. One is the gas fee. Extraordinary gas fee started being required, number one. Second problem was, it started taking a lot of time to put your transaction. Because ultimately you have to wait in the queue. There is a big queue outside. And everybody is trying to put some money. Whoever is willing to pay money, gas fee, even though it was a big queue, right? Because there were so many people who were playing with the game. And there were, of course, other applications being already there. I'm just talking about one application which created havoc in the whole Ethereum system. Good so far? Any confusion in this so far? Right? Now what happened? That this was a tricky situation. And people thought something has to be done. Something has to be done to solve this problem. Otherwise, what happens? If you want to do a simple transaction in Ethereum, you cannot afford it. Do you really? Now, where is Anusha today? She is not here so far. Now, okay, give me some other name. Kaushik. So now today, Kaushik is paying money to Deepak. Okay, Deepak, you are on the receiving end today also. Yeah. So now, if Kaushik has to pay 100 rupees to Deepak, now Kaushik is paying 100 rupees and Kaushik is paying fee of 10,000 rupees. Is it sustainable? It is not sustainable, right? So understand the problem here we are talking about. The problem is that this system became unsustainable. This could not grow any further. So something has to be done, correct? What is that solution? Now, I'll come to that. So everybody started, the whole blockchain industry started thinking about a solution for this problem. Because this cannot go on, very simple. The whole thing collapses. And then after a couple of years, DeFi, how many of you understand DeFi or know the term DeFi? Raise your hand. What is DeFi? Decentralized finance. What does it mean? Can you explain further?
Sir, there is no intermediary of any banking system. Any to pay transactions.
Fantastic. What is your name?
Ram Ganesh.
Ram Ganesh. Clap for him. Sit down. So decentralized finance is a system run in blockchain across various platforms. We'll talk about platforms later. Don't worry about it. Where you don't have any intermediary, but still you can do all the functions of the traditional finance. What are those? Can somebody give me 3 examples or 3 use cases or 3 things from traditional finance? Raise your hand and tell me the answer. No, NFTs, I'm talking about traditional finance. We'll talk about NFT, by the way. Yeah. Banking is a very broad term. Go specific there. Fixed deposit. Very good. What else? Lending. Very good. What else? Could be insurance also, kind of a bigger umbrella of banking kind of thing. A little different, but that's okay. All these things are done in the traditional world where you go and take a loan, you put your money, you get some interest. All these things you are doing there. All these things were made possible in the DeFi world. Now this again became another hit in around 2020 or so. This problem again surfaced. Now boss, this system will not work. Illa is a word in Kannada, I guess, right? Yeah? So, sorry? No, I didn't get that. 1%. Tamil, huh? Oh, okay. So my all South Indian languages are mixed. Sometimes I used some word here and some word there.
So, Silvan is saying it's
Illai in Tamil.
Illai in Tamil, Illa in Kannada.
Illa in Kannada. So Selva Saab, clap for him because he knows all the languages. How many languages do you know, Selva Saab? Sorry? So Mr. Selva Raju, he is your expert trainer. He knows 10 languages. Okay, so what happened? This problem again came, right? Guys, are you with me so far? Excellent. So now this is a big problem. Somebody has to solve. So everybody started looking at the problem in some way. Okay? Now Ethereum also started thinking, how do we solve it? Right? And then there were certain entities which are called layer 2 solutions. We'll talk about that. Now before I get into that, Deepak? We are good so far? Okay. So Ethereum also started thinking, and there is now the question, see, I'll try to discuss things very conceptually. That's what I want you to see. I think you can read about it, you can watch videos, you can do several things which you should do anyway. But my objective of talking to you is to give you some of the very, very fundamental concepts which you will take a huge amount of time to appreciate. And I think once you understand these things, then building on top of this will become very easy for you. And what I have gained, definitely I have done a lot of hard work to understand all these things, which I'm trying to, cover it for you. Make sense? Okay, so now Ethereum started looking at the problem itself, and they proposed something which is called Ethereum 2.0. Right? Ethereum 2.0. So what does Ethereum 2.0 target? What does it want to do? Very simple. That first of all, the Ethereum 1.0 was on which consensus mechanism or which civil resistance mechanism? Proof of work. Deepak, your team is already understanding concept very, very well. I'm very proud of you guys. Clap for yourself. So one problem that Ethereum was trying to solve here is basically, they said, okay, so much of energy consumption is happening, and if Ethereum becomes, in fact, Ethereum is one of the biggest chains today, and you cannot sustain, the whole earth will collapse in the sense due to the energy consumption. So Ethereum had to move to proof of stake. So they said, okay, fine, we will also get into proof of stake. That's a big project, and Vitalik Buterin, you know him, right? So Vitalik is the founder of Ethereum, and he kind of started this. Now, one thing is basically moving to proof of stake, civil resistance mechanism. I'm not talking consensus mechanism because consensus mechanism is a little broader term. So people generally use, proof of work, proof of stake as consensus mechanism, but that is technically not correct. Okay, so let's call civil resistance mechanism where you are resisting your network to get hacked. That's the overall objective. Okay, so one is proof of stake. Second thing, they also, once you move to proof of stake, many of your problems related to proof of work mechanism already they go away, right? And then you are also creating, I would say, more block space. How do you create more block space? Can anybody give me an idea about? Say, for example, you need more transactions to get into a block. What can you do? Sorry? Merge happens. Very good. So basically, merge is a different concept. So what happens? See, ultimately, understand in the crudest term again. So what is happening? We are saying there is one blockchain. It means one sequence of blocks. Correct? Now, all these blocks have some space to accommodate transactions. What if I increase the number of parallel chains? Can I do that? So there is chain 1, chain 2, like that there will be several chains, and all of those chains will be kind of merged into one chain, which is the master chain, which is called in ETH 2.0, which is called beacon chain we call. And ultimately, so you get so many parallel, spaces, correct? So more transactions can come into. So in essence, this process is called sharding. Have you heard of sharding, term sharding? Sharding is a very, typical term used in databases. So whatever words I am telling you, I would request and expect all of you to take note of these words, go and do Google, and you will get to know much, much more. Like Abhishek mentioned earlier, Google is the first skill, right? You should be able to do that. So when I say sharding, you should go back and look at it. What does sharding mean? Okay, so Ethereum 2.0 tried to solve this problem. But then, so other people came, and other people, they started saying that, okay, now Ethereum is definitely trying to do something. We also should try to do something. So that is where you started seeing a lot of other blockchains. Everybody is trying to solve the same problem. What is the problem? Can you scale? Can you scale? Can you make it more secured? I talked about the trilemma. You remember? What were the three terms there in trilemma? Who can say that? Absolutely. Decentralization, scalability, and security. Right? Now the beauty of that, how do you make a network more decentralized? Let me ask this question. So a network is consisting of, let's talk about proof of stake model. A network consists of so many validators. Understand that? A validator, who is a validator? Who does validation? Who is a validator who does validation? Validation of transactions, correct? So now, the question arises that how do you make a network more decentralized? What is the most centralized formula or model in decentralized network? Can somebody, very smart question, Deepak will treat you again if you answer. What is the most important, what is the most conservative, what is the most centralized form of decentralized network? Can anybody say that? Listen to my question. What is the most centralized form of a decentralized network? How many validators could it be? One. Who answered that? What is your name, please? Sorry? Harikesh. Harikesh, very good job. Right? It is very true that I am creating a decentralized network. I am boasting all big things, but I have got one validator. What will this guy do? Whatever this guy does, that is the final decision. Is it decentralized? It is not. Right? So how do you make it decentralized, more decentralized? Absolutely. You guys are talking at the depth of blockchain. Silvas up, right? You are talking at the depth of blockchain, which people who have worked in 2 years, 3 years, they will not talk at this level. Guys, believe me. You are talking the depth of blockchain. So, you increase the number of validators. And what could you do more? Now, if all the validators are within one geography, for example, now that geography may be having some constraint that government says something, or there are some local situations, right? If validator if one particular situation impacts all the validators, then the system is gone, right? So the idea is that to geographically have a distributed set of validators. Another thing what you can do is that, the machine. So what do these validators do? Guys, whoever has come late, I think you have missed something, right? Do you guys think they have missed something? Yeah? I think I would request all of you to come on time, please. So now, what we are doing, so we are increasing the number of validators, right? So that way you can kind of make it more decentralized. But then if you are making more number of validators, then your system response becomes slow, right? Because many people have to validate, right? Third thing, all these validators run nodes, right? They have nodes. How do validators contribute? By running the node software, right? By running the software on their nodes. Now, depending upon what kind of infrastructure, say for example, you want to become a validator. You want to become a validator, and so you have to run a node. Now, I will tell you that if you want to become a validator in my network, and that could be any network, then your hardware requirement is you need to have 64 GB RAM. How many people can do that? Very few. Very expensive, right? I mean, you are talking about something industry grade machines. Not everybody can have that, right? So the hardware requirements of becoming a node is very, very important. And different chains have their different requirements. Now I will come to different chains. So let me first talk about what Ethereum is trying to do, and Ethereum is in the progress right now. They are transitioning from proof of work to proof of stake. They are also doing sharding, which will give them multiple lines of transactions, okay, and all of them. So basically, your speed of transaction, inclusion in the block, that becomes fast, right? And there are so many other things. So if somebody is curious, go and read about it. I may not even know everything here, but then you need to understand what exactly is happening here. Then other people came, for example, Solana came, then you have Avalanche came, Polkadot. Now, we will talk about layers little later, but then all these people came and then they proposed a solution in their own way. That look, ultimately problem is same. People, you are creating a platform, and on that platform, there are applications which are being created, which are called dApps, decentralized applications. And all of these dApps give transactions which get included into the blocks, not blockchain, included in the blocks, which become your blockchain. And you do understand, remember all those Merkle tree, hashes, connections and all of that? What we discussed? Funda is very similar. All these fundas are very similar. But everybody tries to have a different way you achieve a consensus. What is consensus? Consensus means finding which is the next block. That is the consensus, right? Everybody comes to an agreement. That's what is consensus, nothing else. So everybody started thinking on consensus in different ways. So somebody says, okay, fine, my network will need only, 10 validators. Somebody said, no, I want to make it more decentralized. So make the system requirement in such a way that more and more people can become validator. If they say, okay, no, 4 GB RAM is good enough, you also can become a validator, can't you? Become validator and start earning money. Who stops you? But some blockchains said, no, my requirement is very heavy. Why? Because they may have the requirements of running their program, may be very complex. Like EVM, they all have their own smart contract programming platform. That may be very complex, right? So the point is that everybody started solving. Ethereum is doing its own bit in making the system more affordable. At the same time, Solana came, Avalanche came, Polkadot came, very interesting project. We will talk about a little more. In fact, Selvaraju will be talking, in detail in Polkadot development environment. Then we have got a couple of speakers from Polkadot today who will be talking about Polkadot. But before you get into all of that, I wanted you to appreciate this fact that what are these guys doing? Now, Deepak, how much time do I have? 15-20 minutes. Okay, so far so good, guys. Anybody having any problem in what we have talked from the morning right now? Okay, can I proceed? Okay. So what we talked about so many blockchain platforms coming up and trying to do things in their own way. Somebody is focusing on scalability, somebody focusing on decentralization, somebody focusing on security, all those things, right? And that gave an ecosystem of blockchains. Several blockchains. And is it a natural thing to happen? Yes. When you leave the water on the floor, water will go where the gravitation or where the level is low, correct? It's a natural way. And all these blockchains started coming and solving the problem in their own way. But one problem happened there, that all these different blockchains have their own ways of managing things, right? it became distinct islands. What do I mean by that? Now, if you have a currency, now we will talk about currency today also. I think Sneha is having class today only, right? Yeah, we'll talk about token economics, currencies. So what happens, every environment network has its own currency. Bitcoin has its currency, BTC. Ethereum has its own currency called ETH. Solana has got its Sol. Polkadot has got DOT. Like that, everybody has got their own currency. What does currency represent? Currency represents the value creation of that particular network or blockchain. Correct? If you look at it in the normal world, every country has got its own currency. We have our INR, US has got US dollars, right? What does INR represent? Yeah, of course, Indian rupees. Now, don't make it so simple every time. Blockchain is chain of block means don't apply that logic every time, right? Joking. But the point here, what I'm saying, every country has got its own resources. You have got your own production capability. You have got manufacturing plants. You have got services. You have got IT services. You have got different services. You have got your exporting ability. You have got your importing ability. All those things basically decide how much valued your currency is. Am I right or wrong? That's how it happens. Similar to that, in blockchain network also, how much value you are creating as such, where people want to hold your token. Understand that point? How much value, if you have a fantastic game which people like playing, people will go and you say, if you want to play my game, come and buy my token. Come and buy my token. Then your token will be in demand. Then you are creating value. But you create a crappy game which nobody wants to play. Nobody needs to have your token. Your token will be of no value. Right? These things are there. So all these different blockchains, coming back to the point, they have their own islands. And it is very difficult to exchange between these ecosystems. So there are different ways we do, which we call this term as interoperability. We'll talk about it later. So now this became a big problem. Okay, now when I talk about Bitcoin, when I talk about Ethereum, when I talk about Solana, when I talk about Avalanche, all these blockchains, so blockchain term and network term, they are used interchangeably. If somebody tells you network, don't get confused. These are all network. Blockchain, Ethereum network, Bitcoin network, Solana network, or you can call blockchains also. Right? They are similar terms. So what happened when these blockchains started struggling in, so for example, I create something, I acquire something. Somebody talked about NFT, non-fungible token. We'll go into them a little later. But the point is that if you have got an NFT or if you have got some currency in one system, that currency is of no use in other system in general, unless you go and pass the value from one system to another system. Okay, now these are complex things here. So that is where Polkadot comes, and these are all layer 1 protocols. Now I'll make the point clear. Layer 1 protocols are such as Bitcoin, Ethereum, Solana, Avalanche, all these are layer 1 protocols who have their own ways of doing things. Who have their own ways of doing things, such as they have their own consensus, they have got their own security mechanism, they know how to, all those things are very, very unique to these networks. These are layer 1s. Now, Polkadot came into picture, and Polkadot, the founder of Polkadot is Gavin Wood, and he is the CTO and co-founder of Ethereum also, by the way. So he has done Ethereum. He has done the technology design of Ethereum, whole Ethereum. So you understand his level. And from there, Gavin Wood started. So he understood the problems which Ethereum was facing, and he wanted to come up with something which really solves many of these problems. Right? And we'll talk more about Polkadot. I'll not go into detail right now because we have a series lined up for you there. But then, before you go into that session, I wanted to make things clearer for you, that you understand what are you going to learn. Good so far, or any questions? Okay. Have I confused you this morning? Okay. So now these are layer 1s. Layer 0, Polkadot is called a layer 0 protocol. What does it do? So one of the things which Polkadot is trying to do is to interconnect these all blockchains. That is where Polkadot says, no, I am not layer 1, I am layer 0, which is enabling the interoperability across different chains. And then there are so many other things which we'll talk later. Now this is layer 0. Now I also use a term called layer 2. Did you guys hear that, layer 2? Now what is layer 2? Who said scalability? Yeah, what is your name again? Ram Ganesh. So Ram Ganesh, big round of applause for him. Now, one of the ways I talked about Ethereum is trying to solve the problem is coming up with ETH 2.2, moving from proof of work to proof of stake, then doing sharding and many other things. Other chains also started solving the problem in their own unique ways, and that is where you see so many blockchains coming out, right? But then there are some other set of smart people. What they said that, look, I don't need to go and do all these things. What I will do, I will still use the security of the main chain, layer 1 chain, and I will do things offline. For example, I'll give you the simplest example here. So, for example, imagine there are 1,000 transactions which really need to come in a particular block, for example. All of them have to come there. So you have the gas cost, you have got the time problem, all those problems are there. What these guys did, said that, okay, don't do all those things on the main chain, try to settle all these things off the chain, one of the ways, and do the reconciliation and go and post, one transaction on the main chain. Understand the point very clearly. So what they do, they are batching the transaction, and after batching the transaction, they do the accounting reconciliation there and go and hit the main chain, not as frequently. So if you're hitting 1,000 times main chain, don't do that. Do all these things there and go and hit once only. Will it reduce the load? Does it reduce the load on main chain? Yeah? No? I don't think you guys understand. Did you guys understand this or no? Yes, sir. So it is a very, very simple concept. These are called scalability solutions. What does it mean? They make the system scalable. You can scale. You can do 1,000. Typically, these transactions per second is pretty low in all these layer ones, the earlier layer ones. But if you go and do these scalability solutions, what you are doing there, that you are handling many things offline and hitting the main line, main chain, at very increased frequency. These solutions are called what? Layer 2 solutions. Do you guys understand this? Now, layer 2 solutions is a very big subject. How are people doing? There are many projects which are working in this. For example, there are various technologies which are being used here. One technology is called optimistic rollup. Another is called ZK rollup, zero knowledge proof solutions. There are many ways. I think I'll not go into, otherwise you'll get confused right now. But you understand what I'm trying to say here. These layer 2 solutions are basically things where you are offloading the transactions from the main chain, doing it somewhere else, and hitting the main chain, less frequently. How do you do that? There are many technologies, like I talked about, optimistic rollup, ZK rollup, right? There are more basically, solutions. Does it make sense? No? Why such a low voice? People not clear? What is not clear? Yes, sir, tell me. Sorry? Okay, so see, what we will do, we will talk on layer 2 some other time also in depth. But right now you understand this, that you are trying to make the load easier on the main chain. Okay, Polygon is a company from India. I don't know whether you know that. Right? They are also kind of doing this side chain and scalability solution. Fantastic job. So now the technology, as we were talking earlier, the technology is advancing very fast in blockchain. You can't imagine the speed at which technology is changing. And that is where one of the latest technologies that has come is called zero knowledge proof. ZKP. You can definitely, I would expect you guys to go and do research on this. And whatever we are telling you here, if you can follow this in 8 days only, you will have fundamentals very, very clear about blockchain. Are you happy about that? Right? I am excited for all of you. Because, I have done a lot of hard work to get to this, believe me. Okay. So the ZKP, what it does, ZKP says, okay, for example, these are all mathematics. All these things ultimately get to maths. So what ZKP says that, look, if you know some fact, that Kaushik ate 2 bondas this morning, bondas or what is that called? Mysore vada. Kaushik ate 2 Mysore vadas. What did you eat, Kaushik, today? Kaushik, what did you eat in the breakfast? Puri. Okay, let me change my statement. Please sit down. So Kaushik ate 2 puris in this morning, but he wants to tell me that I have eaten my breakfast, but he doesn't want to give me the proof. If he wants to tell me something and he wants to convince me that he knows the subject, he knows the topic, but he does not want to tell me his fact, he can do that. So that is what is called zero knowledge proof, where you are not giving me any proof, you are not giving me any evidence, but you are proving to me that you know the fact. Did you get that? So without you telling me the fact, you convince me that you know the fact and I am okay with that. Now that is called zero knowledge. This is a path-breaking technology, believe me. And after this, all these sessions, we will have something called IBC Continuous Education Program, which Deepak will share with you more details. But then we will have continuous discussions and development skills. In fact, Selva sir will be teaching a lot in those sessions. And I think this will continue. But right now, ZKP is one of the technologies which is path-breaking in blockchain. It's not a technology for blockchain, but it is being used in blockchain.
So right now we have around 40 minutes. Okay. So you can keep that in mind. कि मतलब चाहो तो 20 minutes. 15 मिनट में आपको इन्फॉर्म कर दूँगा.
Okay, so let's do 5 minutes Q&A here. Okay. So should I ask the question or you will ask the question? Me asking the question? Okay. So then let me come within your crowd. Okay. And Deepak, how do you want to reward the people who answer the question?
Yes, sir.
How do you reward these guys who answer the question?
It's up to you, sir. You tell me. We'll do that.
Okay. So let me ask a question that short 256, do you remember? What is short 256? Be at ease here. Don't make it so tight and so stressed. Keep it open. Okay. Enjoy the work. Enjoy learning. Jnanam paramam dharmam. Right? So don't feel stressed. Make yourself easy. Got it? Okay. So short 256, what is the byte length of the outcome? Raise your hand, don't answer. When you do short 256 hashing, what is the byte length of the outcome? That was an easy question. Okay, let me make it more complex. Okay. Okay, I'm thinking of the question. Sorry, sit down. Yeah. Okay, who invented Bitcoin? Okay, that was an easy question, right? Okay, so now I want little lengthy question and answer. Somebody has to explain me the difference between proof of work and proof of stake model. And very, convincingly I want an answer. Who wants to answer? Please raise the hand. What is the difference between proof of work and proof of stake model? Somebody has to explain to me in detail. Who wants to do that? Okay, I see one hand there. Let me come. It's okay, no problem. Guys, listen to him. What is your name?
Yes.
Yeah, please. Please tell your name and then explain the answer. Yeah, go ahead.
Good morning, guys. Myself, Kiran. So the question is, what is the difference between proof of work and proof of
Proof of work and proof of stake.
stake? Yeah.
Yeah.
Sir.
Yeah. Go ahead. Yeah, continue. Okay, guys, give him some time. Yeah.
So 2 minutes.
Yeah. Don't get stressed. Aram se. Proof of work and proof of stake.
The proof of work is defined as a work in which the hashings are used to get an outcome of the program or a definition or an entity. And the proof of stake is defined as what is the work we have done to prove an entity, to make an entity or make an hashing or make a step-by-step process for the.
Okay, good try. Clap for him. Okay. Thank you, Kiran. Can anybody else want to try? Okay, I'll come there. Yes, guys, listen to him. Say the name first.
My name is V. Shubhankar. I would like to explain what's the difference between proof of work and proof of stake. Yes. So actually what miners do is they validate the transactions. So while validation of transactions, we need something to ensure that they don't validate it wrong. Like say for example, we have some transaction that says send this money to this person. If the validators does it wrong, then we need something to say that he does it right. So that's where when it comes proof of work and proof of stake. Now in proof of work, the work that they do, like for example, they need to do something wrong to get their own profit. Now what the validator will do, that he wants to change, suppose he wants to send 5 bitcoins to this person. Now this validator will do he sent 1,000 bitcoins to that person and he will forge it. So then this person will give me that extra money. But in proof of work, he has to change the entire existing blocks to change that transaction history. So he cannot do that. The proof of work keeps a check on the miner that he cannot do something that is against the blockchain. So that's what proof of work is. Now the proof of stake is something else, in which the miner has to keep something at stake. Like it's his own bitcoins. Like since the blockchain is distributed network, everyone is doing it.
So do you guys agree with him so far? Yeah? Okay.
Yeah. In proof of stake, since the blockchain is distributed, everyone is working simultaneously. So suppose if I do something wrong, someone might immediately point it out. So that the thing that I kept in stake will immediately go. So that money that I kept in stake is at risk if I do something at wrong.
Very, very nice. Very, very good explanation. What is your name again?
Shubhankar, sir.
Shubhankar,
sir.
Good job, Shubhankar. Please sit down. So I think you guys understand this. So basically proof of work and proof of stake. In proof of work, you are required to solve some mathematical puzzle, right? Which is too energy, I would say, consuming. But at the end of the day, what you are trying to do, you are trying to protect the network. Ultimately, all these things, be it proof of work, be it proof of stake, what are they meant for? They are meant for civil residence. Let's be non-technical. They are meant for, sorry? No, loud. No, they are meant for, I want the right answer. They are meant for, sorry? Be loud. They are security, who said? Who said security? Okay, give me the mic. Now this time I'll ask you to elaborate further on this. Okay, explain it more. First of all, a round of applause for him. What is your name? Praneeth, very good answer. But explain it. No, you know it. You know everything. You have to explain it.
It's a bit tough, sir.
No, it is very easy. Nothing is tough. Have I taught you tough things so far? Whatever I have taught you is tough or easy? Tell me, you tell me. No answer means what do I read from this? Medium. Okay, so in few days we'll make it easy. Don't worry. Yeah. So Praneeth, what you said is very correct. Sit down. So these are the mechanisms to make the network security. If you don't do these things, you can always create blocks. You can create blocks by doing, okay, don't solve a puzzle, just keep on creating blocks. Who stops you? But that will be unsecured. So security, how do you get? You give some roadblocks in the path of block creation, so that you can't just do like this. I explained to you earlier, right? If you say, okay, no logic here, just go on creating blocks. You can create millions of blocks in an hour, right? But then what stops you, and you were giving the example there, Shubhankar, right? You were giving the example that I gave an example earlier that, person A transfers some money to person B, and after that there are, say for example, 10,000 blocks have been created. And now somebody wants to go and change the transaction. That person can go and change it, no problem. You are free. See, in blockchain, data is with everybody. All nodes, typically, they keep the data depending upon their different types of node. I talked about it. Light nodes, validated nodes, archival nodes, different types of nodes keep different type of data. They run different type of softwares, right? But everybody is in the process, correct? And everybody keeps a copy of the data. Everybody, there is no one database. Now you can always, you are a free world, you can go and change your block, keep and feel happy about it. That in your node you are saying that I have got $1 million, but that is of no value because the rest of the block will slap you. Come on, don't be so greedy, they will tell you, right? So you can do all of these things, but then if you allow people to create blocks just like that, you can go and create 10,000 blocks in an hour, right? You can run it, just run in a loop, done. But the moment you say, okay, no, you can create a block only if you are solving this puzzle, which will take minimum 10 minutes, and that happens random. I talked about yesterday, right? Day before yesterday, right? That happens random. You can't go and say, okay, give me a hash which has got 6 leading zeros. Can you ask that hashing function? No, you can't ask. Hashing function, what gives you is completely random. So if you are looking for a hash which has 6 or 5 leading zeros, you have to go and keep trying. Ultimately you will get something. Somebody may be lucky, they may get little early, somebody may be little late. All those things are possible. But at the end of the day, you need to depend on chance. Right? And that is where you are securing the system by not allowing people. Now this is one way of securing the system, proof of work. Proof of stake, like Shubhankar mentioned, proof of stake does the same security by creating an incentive and disincentive plan. That, for example, if you have kept 5 lakhs rupees in bond, it's kind of bond, right? And then you are behaving mischievously, then network will come and penalize you for that. Do behave mischievously, I will take you 3 lakhs. Will you do that? You will not do it because you know what is wrong, what is wrong. If you are doing something wrong against a set logic, network will find it. And the network will find it, network will penalize you. Will you try to take chance? And I am not talking about 3 lakhs a year. I am talking about there are some chains who have got, deposit of crores of rupees. You don't want to take chance. So now suddenly what happened, the whole context got changed. You're not worried about in doing all so much of energy consumption, but put something smart. See, this world is full of smart people, right? Blockchain has got a lot of smart people, and I am happy that 300 smart people are getting added into the blockchain world now. I mean it. Right? Okay, so now let me ask another question. What is interoperability? Who will answer the question? Guys, don't disappoint me.
Unites the chains in the block.
Unites the chains in the block. Very good. Who else?
Cross-working of chains.
Sorry?
Cross-working of chains.
Cross-working of chains. Something similar, okay? Sorry? Cross-communication between the chains, absolutely. So you understand why are these networks isolated, right? These blockchains are basically, one blockchain is a complete, separate ecosystem. Now there is another interesting thing that I want to tell you. You must have heard of the bridges. So how do two networks talk to each other? They talk via bridge. These are bridges. Now, what happens in the bridge? Now, okay, now, say for example, you went to Korea. You got some Korean currency. Okay, you come here and go to the vegetable shop, buy some aloo and give some Korean currency. Will they take it? Will they take it? No, why? Because that's a different ecosystem. This is a different ecosystem. Currencies are different. So Bitcoin, when BTC, where does BTC get created? Where does BTC get created? Tell me, these are all, are you guys feeling less confident or what? Feel free to give me wrong answers. I like wrong answers more. In the Bitcoin blockchain, give her a big round of applause. What is your name? Janvi. Very good answer, Janvi. So where does Bitcoin get created? You heard her? Which blockchain? Bitcoin, right? But now if you take that Bitcoin currency and use them in Ethereum, how can you do that? It's like Korean currency being used in India. How will you do that? Sorry? No, one at a time. Huh? Who will do conversion? Which bank? There is no bank here. Illa. No bank. Sorry? Why will validator? Validator has put his money, he is earning profit, nothing else. Why will validator do anything? What is that? Nothing. Why? How? Tell me. How will you use it? You want to use Bitcoin in Ethereum. How will you use it? It is being used, right? You know that, correct? It is being used, by the way. How do you use it? Sorry? Transactions means? One thing for one thing. So, one thing? Yeah, how? You are getting close. Puneet? No.
By getting tokens.
By?
Getting tokens.
You're getting close, but you have to explain this to me. Yeah, you were saying something. Interoperability is a broad term. Where do you stay in India? No. Yeah, tell me who. Do you get the question? How do you use one currency into another blockchain? Sorry? Huh? Will? From where? No, but no, it's not buying the coin I'm talking about. Why? How does this currency has a value in other ecosystem? What do you do for that? Converter is fine, but converter is the front end. What happens? ultimately, see, this network should identify this, right? It has to, first of all, it has to follow its own standards. Bitcoin is a different standard altogether.
Sir,
Yes.
sir, first
Sorry? Yeah.
I will sell the bitcoins, earn some cash. With that cash, I'll buy another currency. Is that right? Like I have exchanged literally, right?
In the same direction. By paying the same. No, I mean, I'm talking about the mechanism here, Janvi. I'm talking mechanism. Yeah. Saying something here? Okay, now let me explain to you. So really what happens that there is, understand the point, there is no bank here where you go and put dollar and get rupee, right? You are so stressed, any problem? You are getting it? You are not getting it. You understanding? Okay. Feel free guys. So what happens typically, there is no intermediary here. So how does it work? So there are, what you do, somebody will do what, and this could be anybody, they will go and, deposit Bitcoin in one place and create an equivalent currency into the new, network. And there is no bank and all. Somebody, if you really want to do that, you can do that tomorrow. But people have to trust you. Because when you say that, look guys, I have kept $1,000 of Bitcoin here and I am issuing $1,000 of Bitcoin in Ethereum system called, Ethereum Bitcoin equivalent, something like that. And then this Bitcoin in Ethereum follows the standards of Ethereum. Then only it can circulate. Bitcoin cannot circulate here. For circulation, guys, are you getting the point? For circulating of Bitcoin in Ethereum network, it has to follow the Ethereum standards. Okay. Now, what is the name I forgot? Ram Ganesh. Ram Ganesh may be acting smart. He will go and tell the world that, look, I have kept Bitcoin, don't worry. And he is illa. No Bitcoin. He is just running the Bitcoin Ethereum equivalent in Ethereum. Correct? You can do that. Who stops you? But then you have to have that, credibility in the market. Right? And now here comes the concept of exchanges in the blockchain. Like you have got NASDAQ, you have got stock exchange, BSE, NSE and all that. We have got similar concepts in blockchain also. So how much time do I have? Because I can keep on going. Break dena padega? Okay, so your friend is saying people need a break. Okay. Okay, break given. Chalo. Guys, okay, we'll meet after the break.
Guys, we'll reconvene in, it's 11:15 now, we'll reconvene at 11:25, right? 10 minutes, sharp.
Okay, am I audible right now?
Yeah, okay, we can hear you. Yeah.
Who here have joined Discord? Raise your hand, please.
I have one mobile number.
The compulsion try it via another email. Okay guys, so we'll begin with our next session. Deepak.
Yeah, ready?
हाँ
11:30 है ना?
35 है हो ही गया
स्टार्ट करो.
Today I need 5 minutes slot on the screen. Okay. So basically the volunteers, yesterday volunteers
Okay, guys, may I have your attention, please, everyone? Please settle in. Guys who are entering right now. Students who are standing. Guys, everyone, please be seated. Guys, quickly take your seats. All right, how many of you all want to learn how cryptocurrencies get the centric value to them, like how the value is created in a crypto, right? So that's where the token economics comes into the picture. So next session is exactly that, and to cover that we have a person who has actually worked in very much detail on the same with our partner firm, which is the Nitro Network. So I want to call upon Sneha Bharti, Marketing Manager at Nitro Network, to take the next session on token economics. Guys, please give her a huge round of applause. Sneha, the stage is yours. Requesting you to please begin.
All right. Thank you so much. and what user experience in token economics model represents. And then I will move forward. I will define just outline the process of token represents an asset and a utility. When I say that an asset and utility, it means basically that that currency is backed with certain kind of uses being done and certain kind of supports the token circulation and the management itself. When I talk about the assets, you must be well aware about everything in the
ఇంటర్నెట్లో అయిపోయి
Okay, now okay. It's a certain amount of
net connect
time. So cryptocurrency just act as a money only, like the fiat currency acts. And I will just give you example of token and cryptocurrency. In token, you can take example of our token and gas, or you can also look at multiple. For example, we have I will say gaming tokens currently are very famous, right? So gaming currency or a token, whenever you are playing game, you earn that token while playing the game as a reward, and then you use the same token, the game itself, to pay to upgrade yourself, your skill, or whatever avatar you are using in the game. So basically, the token has a utility. While when I talk about Bitcoin and Ethereum, it is solely used as a currency. As I said, people use it nowadays. Vast adoption of cryptocurrency has been done. People are using it to buy stock and sell stuff there. Now coming to the next difference between the token and cryptocurrency. Token generally, operates on an existing network. When I say existing network, it basically means that so most of the token don't have its own blockchain. They actually works on the blockchain of which has already there in the ecosystem, which we call layer one. And when we talk about layer one, there Ethereum is there, and then Polkadot, Solana, all these products have their own blockchain. Okay, when a company introduces a token on their chain, then it is called a token there. For example, our native token, which is AdGas, it is on the Avalanche chain. We are using Avalanche blockchain to build our entire token ecosystem there. While cryptocurrency, as I said, Ethereum, they have their own blockchain. Now coming to this is where comes the third difference. When I say that token is generally get minted while cryptocurrency gets mined. Now understand the difference between minted versus mined. Okay. So far from 2-3 days, you all have been learning about how blocks get created, right? How hashing function works there, and that's where the cryptocurrency comes into the play. So whenever a new blockchain gets created, it gets added to the previous blocks when it gets validated by some people, right? And in order to validate that particular block and to validate that particular transaction happening on that chain, you require a lot of energy, complex problem solving there in order to validate it. So when new blocks get added to that particular chain, it is called kind of like mine. So the person who validated it, who was successful in order to validate and get it added to the chain, gets a certain portion of the currency there. That's when a new currency gets mined and is rewarded to that particular person. Now coming to what then is mean by minted, right? So when in token, when I say it's minted, it basically means that as per the need in the token economics itself, we just mint it. There is no one who is there validating because we are not operating, we don't have our blockchain. We are operating on the existing blockchain itself. So whenever I will say whenever that is a requirement in the ecosystem, we basically introduce new token into the system there itself. That's why we call it minted. For cryptocurrency, we call it mined. Now coming to the very first difference which I stated already, that token has multiple uses and utility, I will say, with respect to when it comes to differentiating from a cryptocurrency. Cryptocurrency just works as similar and very close to as a fiat currency works. While token has a multiple uses. Token acts as an ownership, or it gives the right, like you buy shares in for the public companies, right? Then you buy shares, if you have already, it's fine. If not, let me tell you, when you buy shares, you get a right to vote. Whenever there is a meeting happens, they send you an email that this thing is happening, this kind of new changes we are bringing into the company. We would like you to vote, being a shareholder of it. So token has multiple utilities. As say, it gives you right to vote, and then token also is being rewarded. So whoever is involved in your entire idea, when I say about project, then you introduce it. Whoever is working on the project, different stakeholders, you basically reward them in one way or another. The third thing also, token generally used is for fundraise. You must be hearing about ICO happening. ICO is like when a project goes to public market to basically raise the fund. So they introduce the token, and the investor basically buys those tokens. That's how they generate the fund there. So this is the basic difference in between the token and the cryptocurrency. Now I will move forward to the basics of token. I'm sure people who are really interested in cryptocurrency must have visited CoinMarketCap at least once. So when you visit cryptocurrency, and there is token, and then the token is being subdivided or subcategorized into as per their uses. Some token are generally used just for I would say financing purpose, where you earn token or you use token just for lending, borrowing, while some token are just backing non-fungible tokens on the project itself. Some tokens solely being used for in the gaming world or the metaverse world for the participants who are participating in the game in the metaverse. Okay, so these are the different categories you can break it down. Now coming to the second most thing, which is very common when you are creating your own token and doing a research, you should know what does it mean. So if you see here, Bitcoin signifies the name of the project itself, and then you see, in the caps there will always be 3-letter, 4-letter, or 5-letter words there. This is called a ticker. Ticker is kind of like symbol through which you identify any trading token or the public token in any of the exchanges. So Ethereum, BTC, their ticker is Bitcoin's ticker is BTC, Ethereum's ticker is ETH, USDT, which is like popular token there, is its ticker is USDT. I hope this is clear. Now moving forward, the third thing you should know about is the market capitalization. Okay, market capitalization is nothing but the total number of tokens of that particular project versus the price here. So if you will see the Bitcoin price, it has been disclosed as of yesterday evening. So this Bitcoin price is 16,700 something. Okay. Now you take the number of Bitcoin in the circulation. If you multiply both, you will get the market cap of this. What market cap signifies is that how many tokens are there into the circulation, what is its value, and as a whole, what the project's valuation is there at the particular moment. Okay. So when you say that Reliance is of, let's say 3.1 trillion or billion, worth, that when we say that is basically the valuation. Okay. Valuation of the company or the project itself. And let me tell you, when you introduce any business idea, one of your goal is to basically increase the value or the market cap of your token or the project itself. So it is one of the important parameters you should look for when you are designing your own token. That your idea should be sustainable enough. Here, when it comes to the token economics, okay, everything works on demand and supply itself. The higher the demand, the higher the value of a token goes. So now, when I say that in circulation, it means certain amount of token has been reserved, been restricted, locked in one way or another. It basically means we are decreasing the supply to go out into the market. When you are decreasing the supply of certain things, and there is a demand continuously coming, just imagine what will happen there. It is supposed to go there that the value of the token will go up, right? Now I will go down to the next slide. Just give me a second. Now let's come and talk about the types of token. We got the basic how to identify token, categories, market cap, ticker, etc. Now, what are the different types of token out there currently? So, if you search, you will find a lot many results in the Google itself, the types of token. But if you go break down on a higher level, it will come down to 4 types only. First one is utility token. So when I say utility token is the token which is being used in the ecosystem of a project itself. When I say ecosystem of project itself, consider example of a game token. Okay, there is a crypto project which are into gaming and they introduce a token through which you are able to participate. So if you have that particular token, you can buy a avatar to start with, and then once your avatar is there, you start playing. While playing, you start earning more rewards in the form of tokenism. And in order to upgrade your skills, to go to the next level in the game, you basically pay in the token whatever you have. So that token is being utilized in the ecosystem itself, right? So when a token comes with its uses, you can by US dollar. Okay. So any token which is backed by standards such as gold or dollar, even you can use INR. Okay, that is known as commodity token. Now, why we use or introduce commodity token? Just to reduce the risk and to reduce the volatility of the same. If you will look at the price of Ether, it will always be USD dollar one. What the I will say the theory behind it is that if you are holding or buying one USDT, the company or the project is actually keeping one USD dollar in the custody on behalf of you. So they are creating risk free kind of thing for you, that its price will be sustainable when it is backed by certain assets such as gold. Is basically means if you look at the price of gold, it is more or less less volatile and it is more standard there. So that creates a less volatility, and people then think that okay, it is backed by something else. In any God scenario something happens, they can actually liquidate the asset they have put into the custody on behalf of this. Okay, and we will get our money back. So that's what the commodity token is. Now coming to the security token. Okay, security token is, I will say, the shares. Okay, today you own the share of Reliance. It basically means you are owning ownership in the Reliance company. 30-20% of Reliance share. It basically means your decision matters a lot. While if you are a retail investor, a small investor, you might have just 2 or 3 shares of Reliance. Still, you get the right to vote, and also you have a right to gain a certain payouts from the company's revenue. So security token works similarly, very similar to the equity shares itself. You have ownership, you have right on the company's profit. So company, whenever they will have profit, they announce dividend or something, you are supposed to get that dividend there. Now coming to the fourth one, which is asset token. So I will say asset token are where it comes your cryptocurrency. It is just to facilitate or I will say substitute the fiat currency itself. Currently, Bitcoin, Binance coin, also BNB, these are, very much used in order to buy and sell things there. So access token is basically your cryptocurrency there. Now moving on to, token model here. Whenever there comes a model and there comes a word economics, it cannot go without the demand and supply thing. That's why I have kept a weight here. And when I talk about demand and supply, so when you are modeling, how will exactly you think about that? How will I create demand? How will I, handle the supply out there, right? So there are two things which you always have to take care of in order to build the basic of that demand supply, the equilibrium balance out there. So I will say first one is deflationary and the second one is inflationary. So when you are designing token, think about it. What kind of token you want to introduce? Do you want to introduce a token which is fixed in number and that fixed amount of token is always being circulated? So basically think of like that there is you fix the size of pie, and now with the increasing demand, more and more people are coming to take a slice of that pie itself. Now the pie is not increasing, but the people who want to have access to that pie, the number of people are increasing. So basically demand is increasing there. So what will you do in that case? The price of each of the slice, I will say whatever the smallest segment will be, it will keep on increasing. The highest bidder will get the slice of that pie. Okay. Now, in the inflationary model, one drawback is there that it cannot be used if you are creating any business idea where you want people to be incentivized, especially in with 3.0 projects, where we are saying the owner or the creator of the data itself will be monetized. Okay, they will be earning from whatever they are creating. In such scenario where you want people to earn and incentivize from the system for participating, contributing to it, deflationary token won't work there. Because if you have very fixed number of supply, okay, at the end of the day, people will know that the fixed pie is gonna be exhausted, only certain people will have access to it, and new people coming up will be thinking that I am anyway not going to get incentivized there from this fixed pie, right? So this kinds of demotivate also there. Now coming to the inflationary token. Okay, so inflationary token are highly being adopted by the projects who wants to create an incentive model out there. Okay, why? Because here even here works two kind of things. You can fix the maximum number of the supply you will ever create. Like in Bitcoin, there is a maximum supply it will ever be created, right? Many projects have introduced 10 billion is what we will ever create in the ecosystem. Okay. Similarly, here you can fix the supply. You can keep it unlimited also. But if you are fixing it, there are different models being used here. Some say that our max limit will be this, but we will be reaching that max number in a certain number of years by minting it as and when required. Some uses some kind of I will say formula or the rate itself to start minting of the token. So that's how the inflation works. Okay, so major difference is there. The definite number is created. Here you can create unlimited number. Even if it is definite number, it is there. It gets created in a certain way so that the new people joining gets incentivized time to time. Okay. Now coming to the user experience of token. We always talk about the user experience when it comes to a product or when it comes to a platform itself. That what kind of experience the user is getting. Now think about like what a token can give in terms of user experience, right? Just imagine, you are holding a Bitcoin. What all things you can do from Bitcoin? That actually counts as your experience with the Bitcoin, right? And today, in order to earn Bitcoin itself, it has to be minted. For that, you need to participate in validating a particular block being created out there. But not everybody is skilled enough to do that. Okay. So here, when I talk about user experience, there are basically two kind of user experience you can create when you are thinking about designing the token itself. One is a user facing, second one is layered. When I talk about user facing, it basically means the user has the ability to basically, handle the token directly. So basically, I being a user, I can actually participate and create the token or mint the token itself in one way or another. I can be a validator who might be validating it. I can be a person who might be saying that this transaction is, successful or not successful. All those kind of things I can do. That's what the user facing that. But user facing token requires a lot many skills. Not everyone is there. Now there comes the layer token. They don't have their own blockchain. You don't have to perform any kind of functionality there when it comes to its program, when it comes to creating the token itself. It is built on already existing token. All you have to do is create the use cases for it. Okay. When I say about use cases, like in how many ways you will be using that particular token, in how many ways you are giving a particular person who is coming to your project to use your token there. That's what the layered one comes to. Now, this is the very significant thing. Till now, I just covered all the basic things about the tokens. Okay, its type, what kind user experiences consist of, and then also the very basics of it. Now, when it comes, since you are participating there, trying to ideate about the idea, okay, what can be created for the Web 3.0. So you might be trying to introduce that when a certain person is coming to your project or the idea you are creating, what they will be gaining. If they are earning something, how I will be managing that earning, right? How much they will earn, how they will spend the amount they have earned. Apart from my ecosystem outside our project, how they can use all our token itself there. So that's the entire thing comes into the token modeling and management. I'm just gonna give an overview because it requires a lot of calculation, projection also. But let's cover the basics today. Okay, so in steps one, whatever till now I covered, right? You need to find the name of your project, the ticker, and the type you will be using, whether you want it to be utility token, security token, asset token, or commodity token. You will be defining what type of token you want to introduce. Then this third thing you will be defining is the experience, whether you want to create your own blockchain, want certain kind of people with certain kind of skill to validate it and create the block itself, or you just want to use the existing layer and make it the user very much friendly for them to get attracted to your project and start working or participating in it, whether it's come the layered one. And and then you will fix what kind of model you want to adopt, whether you want it to be deflationary where the number of token is fixed, or you want it to be inflationary where you will be minting number of tokens as per the requirement time to time to basically reward people there. Okay. Now coming to, for this you will require a lot of research before defining your token for the project itself. Take the help of secondary research, all the projects, top 10 trending projects out there in CoinMarketCap. Look at their token model, study them, look at their market cap, how they have handled the circulating supply, how they try to, fix or restrict or lock in a certain portion of, their token pie. What are things they are doing. When you will study that, you will get to know more and more about it, and it will give you clarity to define your token itself. Now coming to the, once you have the basic things covered. Now you have to think what are kind of use cases you will be creating. Okay, and when I say use cases, just think of I will say, let's take example of everyday um, vegetable, tomato, let's say. Okay, now tomato has been introduced by the farmer. How many use cases can you think of tomato out there? Okay, it's I cannot interact, but with having really interesting question, just think in your mind how many use cases are there of tomato currently. So if you think, a little deep, tomato is not just a vegetable being used in your everyday, food you are cooking in the kitchen, like sabji we say, right? It's not just used there. The company is creating the sauce from the tomatoes, right? Then one segment is tomato sauce there. Tomatoes also have a lot of many, I will say cleansing property. That's why it is being in cosmetics also. The tomato being used in cosmetics is also one of the use cases. Now think more, okay? Now there are a lot many restaurants out there, and every day they have a certain amount of dishes they prepare in which tomatoes are being used in different ways. Now tomato being used in restaurants for pasta, pizza, and many more, right? This is also one of the use cases. So it basically means the more use cases you create, the more demand you are creating for your token itself. The more demand is there, the more the value people like to buy, have your token, use it, the more value token appreciates in the value itself. And that's what affects the market capitalization, which I talked in the very first slide of itself. So think about in how many ways you can create a use cases of your token. Now the second thing in the step 2 comes the allocation. Okay, when I talk about allocation, let's say that you have 1,000 tomatoes. I'm taking the example of tomato to make it or simplify it. You have 1,000 tomatoes. How you will be allocating it? How many of that 1,000 you will be giving to the hotel people? How many of you that tomatoes you will be distributing it through the hawkers so that it reaches the your houses or the houses of people? How many of them you will be providing it to pharmaceuticals companies, to create the medicine, or how many of them you will be sending out to the cosmetic companies so that they can create the cosmetic out of it? How many of them you will be giving it to the restaurant owners? So that's what the allocation consists of, how you will distribute the token you are creating or minting. Okay. Now coming to the liquidity there. Now once you allocated it, right? Now tomatoes are in the hand of restaurants people, tomatoes are in the hand of cosmetic companies, tomatoes are in the hand of the normal people at the normal houses itself. Okay? Now it's there, out there everywhere. How you are managing it? Let's say tomorrow there is a high demand coming. Some, maybe you were operating in India, while someone from US came and said that, hey, I need tomato. Okay, now the demand came from outside. How you are managing this when you had the 1,000 token so that there is enough enough circulation in your home ground, then you are also trying to fulfill the demand coming from the other side as well. And how you are also managing when, let's say, at a certain person time came when, let's say, you were minting 1,000 or farming 1,000 tomatoes in a month, but next month some crisis happened, some climate thing happened, you produced only 800. Okay, when you produced 800, how you are managing that scarcity of 200 with all the participants who are eyeing or sitting there to receive tomatoes from you? So all these things comes into the liquidity. Basically, you need to think about, like, you need to have a treasury where you will keep on with every mint will be allocating a certain portion to manage such kind of demand and supply to create the equilibrium. If there keeps on having high demand and supply is very, very less, the value will be touching sky high and only it will be in the hand of only handful of people. That is also kind of dangerous. Let's say tomorrow, if it is in the hand of only handful people, maybe 10 people, they go into the market and see that value of tomato rise from rupees 10 to 1000. They see their profit, they go and sell it into the market, and immediately everybody started selling it into the market. Suddenly, supply is overwhelmed in the market. The value of tomato again came down maybe below the 2, maybe 6 itself. So this management is what comes under liquidity, how you will be managing. Now, coming to the step third. Step third is basically when you have everything fundamental covered. This is where you keep in mind. You do the projection based on your historical data, how people are basically using your use cases, how much of token is being maintained, is being used, is in the circulation, etc. Now there is a new thing which comes from burn, which I have not introduced so far. It is very new to you people. Now burn is a concept where we basically remove a token from the circulation for forever. Basically, what we do in a programming level is that we basically send a token to a null address from where it cannot be retrieved at all. So basically, we remove the circulation of that token from the supply itself. So the burn is also being done in order to reduce the supply, so that there is when there is enough demand, you reduce the supply. What happens? Price rises. That's where the burn comes in. There are not many ways to burn. I will talk about gas burn later, how we are burning it. But if you do step 1, step 2, step 3, the end result what you are looking out for is the rise in the demand of the token, which will appreciate the value of token. That's what ultimately matters when you think all about the token itself. People are asking for your token. People are ready to pay for your token. As a result, your market cap valuation of your project is going high. Now I will quickly walk you through, guys, the case study of Nitro Network. At Nitro Network, let me just give you first a brief about what we are doing at the Nitro Network, okay? So in a simple language, if I have to say, I will say that, at Nitro Network, we are trying to create a smart life for every human, so that whether you are individual, whether you are a business, you have a business, or you are a government, we are trying to create a smart solution for people which will create a smart life for you. And what we ultimately aims is to enhance the quality of life you are currently living. In a hypothetical scenario, in current scenario, but I will say in coming years, if tomorrow, in place of your mother, you are sleeping in the morning, you have to get up, go to your college, attend the lecture. If in place of your mom, if tomorrow the window curtain itself goes away and the sun peeks on your face, the fan gets switched off at a particular time when you have to get up and go get ready for the college, if this happens automatically, know that Nitro Network reached your house. That's what we aims to. And let me tell you, we are not trying to eliminate here the role of your mother. Whatever your mother currently is doing, we are just enhancing her role. Now she will be saving the time she is utilizing just to wake you up for half an hour, coming to your room, removing the curtain, switching off your alarm fan, anything she is doing just to wake you up. She can put her time and effort, maybe to do something for herself, something for your family, something to learn a new skill itself. Okay, so in short word, we aim to enhance the quality of life people are living there. And how we will be doing it? We will be doing it through Internet of Things and private network. Private network is basically where the sensors talk to each other. They require a network in order to talk to each other, right? That's what the private network are for. Alright, I will just give you very basics, which I covered in the very first slide. Name is Nitro Network, as I said, And then token or the ticker itself, we have our token name and gas, and the ticker is and gas. You can go and check in the coin market cap also. We have utility token. When I say utility token, I will talk about what all kind of utility we have created so far. Utility and use case are the same, just don't get confused. So we are utility token. Now coming to the token model, are we inflationary, are we deflationary? Now the interesting answer is we are both. We have introduced a very well known and researched model, which is burn and mint equilibrium. So when we say burn and mint, it is basically we mint every month. That's what makes our token an inflationary token. While with every at the end of every month, with our profits generated from the revenue of our company, we use a significant portion of our profit to burn our anchors, or basically remove it from the supply, which basically decreases the size of the pile, creates a deflationary action for it. That's why our token model is both. Now I will say there is no very fixed model right now, in the cryptocurrency. The industry itself is very experimental and evolving, and there might be coming more and more, such modeling. There are actually is, but currently we are following inflationary displacementary model. Now coming to the user experience, we are layered. We don't have our own blockchain. We are layered on Avalanche chain. I'm pretty sure you must be heard about Avalanche. If not, please go search. It is chain like Ethereum, but transaction and gas fee is very low, and transaction, I will say, speed is very high. That's why we have moved from Ethereum chain to Avalanche there. Now, when I was talking about the step 2, where you have to think about, allocation, you have to think about how you will be creating demand supply, managing the liquidity. This exactly what we will be doing. If you see token distribution inflation chart, this shows that how we will be minting over the years. We are not saying, we said that, our max supply is, let's say, 250 billion. We did not say that tomorrow only itself we will be minting 250 billion of anchors. We said that over next 50 years, with us following a certain rate, we will be reaching the max supply. So just imagine if you are a person at night on network, know that you will be being rewarded, being incentivized for the next 50 years. That's what token economic model should be in Web 3.0, where incentivization is the most priority. So if you are thinking about any idea, trying to design a model, think about how you will be incentivizing. For that, you need token to be inflationary out there. Now we created an inflationary model because we wanted whoever is using our IoT sensors, using our network, they gets rewarded for it. We actually want people to adopt to IoT, Internet of Things. For that, we are incentivizing them because we want a better version of world itself, which is smarter tomorrow. That's why it is inflation. Now we distribute a token, right? We said that hey, you buy our sensor, you use our network, connect it on our network, and you are living a smart life. At the same time, you are earning ANCAP, okay, for using it. Now, if I keep on giving the rewards, but I'm not managing, but I'm not thinking about the demand, maybe tomorrow ANCAP's value will get devalued there. So that's where we introduced our burn also, where we said that through the network uses, through our marketplace from which we are selling our sensors, and the gateway to create private network, a significant portion of the revenue we will be using to remove the token from the circulation itself, creating the demand. That's why, which will contribute, or I won't say directly gets contributed, but it will contribute in appreciating the value of the end gas itself. So this is all about allocation and how you will be managing the demand and supply. Now comes to the use case as I was talking about Tomato. As many use case you create, that many demands gets created. The more the demand is, the higher the value of your project or your token goes up. So we introduced multiple use cases in which you can use and gas. Okay, so we are giving you, if you are using our network, you are earning the reward. We have NFT also. NFT basically represents, I will say, a stake in smarter tomorrow itself. If you have NFT, know that you are contributing to make the world a better for someone, for yourself, your neighbor, or the world itself. So when you stake that NFT on our platform, you earn ANCAS every 30 minutes. And then we have found also, now you earn ANCAS, right? What will you do of ANCAS? If there is no use case in order to use ANCAS, that's futile, right? That's where we introduce farming also with our partner Pangolin. So you basically go onto their farm, stake your ANCAS, you earn a interest rate of 100%. Okay, then we also introduce Genesis reward out there. I will say it's for our long-term investor. So whoever has believed in your project, always try whoever is coming and adopting your project idea earlier. Keep in mind, especially when you are building new Web 3.0, that early adopters, early joiners should be highly incentivized because they are the one who will be working as a word of mouth advertisement for your project. So make sure you count them in there. Now comes the staking rewards. I say that farming is with our partner Pangolin. Staking is our native. You can come to Nitro Network website, go to our Endcast web page. There you will find the staking platform where you go stake it and earn interest on that. Then there comes the IoT and the investing incentivization reward where we are saying that if you are adopting our gateway, creating a private network, and trying to create the adoption of IoT, or you are basically trying also become our, act as a business partner or business hand for Nitro Network. You go out, talk to your friend, family out there, let them know about the uses of IoT so that they adopt it to create a smarter life for themselves. You will be incentivized for it at Nitro Network. So we created multiple use cases. You come participate whichever way you want to participate, and you will be incentivized for it. That's how your token should also work. And there is many more to come here, and we will be introducing it soon. Now coming to the third thing where I was saying that you need to handle the projection and the discretionary action itself in order to create the demand. So this is where how we have done it. We are minting anchors, if you will see here, in order to reward people for participating in our ecosystem. Then when we reward, it goes into the hand of people, right? I had money, I gave it to 3 of my friends, now 3 of my friends have access to that money. That went into the circulation from me to the 3 more people there. So now Cash went into the circulation to the different participants. It is going to the supply. Now how we will be creating the demands or reducing the supply itself, that's where I was talking about. We have marketplaces from where you can buy IoT sensor. We have marketplaces from where you can buy NFT. So every transaction happens on that marketplace. There is, the charge out there, the 33% of revenue generated from, 33% of not revenue, profit generated from the marketplaces and the network uses. We will be using it to burn and gas, creating or reducing the supply and then creating a demand for it. I have not talked about 2 things that we are not just into, creating IoT adoption through direct B2C customer. We are also trying to create IoT solution for businesses, enterprises, and the government entities as well. So that's a kind of like, big ticket size kind of projects out there. So we will be utilizing the profits of those big projects for which we will be providing IoT solution again to burn the end gas there. So that's how we will, with the time, although currently we are minting it, but every month we are also dedicating a certain portion in order to remove those from the circulating supply. So that's how we are creating the demand for it. So that's the end of the session, I will say. I have covered pretty much here. So if anybody has any questions, just let me know.
Guys, a huge round of applause for Sneha, first of all.
Thanks, Deepa.
And do check out Nitro Network, our partner firm. They are doing some brilliant things. And Sneha has given you a good description about the same. Another thing that Sneha has said was about the use cases. Guys, if I can have your attention, if there's anything more important than this, then you can step out of the room right away. Yeah. If there's anything more important than what we are doing here, you can step out of the room, you can go discuss and then come back. So another thing that she mentioned was about the use cases being the essence of the platforms, of the token. So do check out how that entire thing works, and obviously you can come up to Praveen sir and Salva sir to discuss that even further, and reach out to her on LinkedIn or Twitter, and she'll be able to help you as well. Are there any questions for Sneha? Yeah.
So guys, just want to add a few things about Sneha. Sneha is one of the persons who understands finance, marketing, economics to a great depth. She is an alumni of IIM, and she has been doing a phenomenal job, and I am sure you would have got deep concept about how these currencies function, how exactly they create value, and how do they maintain their value in the ecosystem. So thank you, Sneha. Thank you so much for sparing your time today.
Thank you, sir, and thank you to the IBC team for having me.
Yeah, Sneha, we have a question before you sign off. Yeah, please.
Yeah, sure.
Good morning, ma'am. The question is that which one is the best option for me, whether buying a cryptocurrency or investing in it?
Okay, question rightly. So if you are buying a cryptocurrency, basically you are investing it, right? So let's say tomorrow you go into any of the exchanges out there, you are trying to buy a Bitcoin, right? So it's basically like you are investing. Well, if you are talking about investing is generally a long term, okay? So if you are buying it, keeping it for months, maybe a year or two, depends on what your long term horizon is there. And I will advise that if you are buying cryptocurrency or even investing, just look at the project's fundamental, what the project is doing, how many of use cases it has created, what kind of token model it does have. Is it containing just inflationary, minting unlimited, giving it to the people just for the sake of it? What it do is backed by certain kind of real world use cases. There are multiple projects who have introduced a token where their token is currently backed in the real world itself. For example, Solana's NFT. You buy their NFT, you can go to the Solana's offline stores and you can buy the stuffs from those NFT. So they actually created a value or the real world use case for it. So these kind of things you need to consider whether you are buying a cryptocurrency or investing. So buying or investing is the same to answer your question, but depends. Investing is always a long term phenomenon. So if you are buying it, keeping it for a long term, understanding that its value will rise in the coming years or the days, and you are keeping it from a perspective that you will get appreciated value in the coming years, then always opt for investing rather than just buying and selling. It can be just buying and selling is always a risky thing there.
Thank you, ma'am.
Thank you. So once again, the use cases, guys, a huge round of applause first of all.
Okay, thank you guys.
Thank you for joining us, Neha. So it's all about the use cases. If you're planning on creating your token, also figure out where all it will be used, what is the real world value of it. And if you want to discuss more, you can obviously come here, discuss with the Pandits, Mr. Praveen sir and Salva sir, of course. All right. We have the next speaker join us right away, and we'll begin in a few seconds.
So guys, the session which Sneha took just now, that is the backbone of the whole, the blockchain cryptocurrency system. So I think you should definitely go and watch these videos again if you really need to, and kind of try to understand these things.
Absolutely. So now we will move on to the next topic, which is, guys, I'd like to sincerely remind you, and also when I say sincerely, I mean seriously, if there's anything which is more important than what we are doing here, you are free to leave the room. You're free to go and discuss outside and come back. I am trying to avoid it, but I'm seeing a lot of people still persistent on doing the same thing. Don't make me just, come and pick you particularly and then ask you to do certain things. Let's not do that. Let's not go there. Let's respect the time of the people who are here. Okay, so moving on, we will now talk about the next topic, which is Polkadot Environment Architecture Overview. And for that, we have Mr. Varun Gyanchandani, who is a senior engineering manager handling blockchain and AI at Giant Protocol. It's right on the screen. So Varun has been a vital part and a partner with IBC Media. He was also with us at Alt Hack Hyderabad, and he was also one of the jurors who shortlisted the winners at the Hyderabad Hack. He's a man with great depth and knowledge. So guys, make the most of this opportunity and do ask questions if there are any doubts. So let's welcome Varun with a huge round of applause. Varun, thank you for joining us again. It is a real pleasure to have you, and the stage is yours. Please, let's take the conversation ahead.
Thank you so much. It's a pleasure to be back to IBC, and it was an amazing event earlier also in Hyderabad, and that's the reason I decided that why not, kind of share the knowledge and learn from each and every, even the members who are actually presenting. So the earlier presentation was pretty nice, got in-depth understanding of how NITO network works. So hi guys, my name is Varun Gyanchandani, and I am from India, Hyderabad itself. I've been doing blockchain and AI development from past around 7 to 8 years now, and hardcore into blockchain from past 3 years or so. So we have our own layer 1 chain, which is known as Giant protocol. But more than Giant, I am going to cover about the Polkadot ecosystem. I'm sure you guys would have already started going through some material on Rust and Substrate. So I'll give you a brief introduction about that, and we can take some questions after that. Does that sound like a decent plan?
We have yes in the crowd.
I'll quickly share my screen, and let me know once you're able to see the screen. Is the screen visible?
Yes, Varun.
Okay. So today we will be talking about in depth about Polkadot, and when I say everything basically around blockchain. So first and foremost, a brief introduction about what is blockchain. It is nothing but a distributed ledger. When we say ledger, basically the entries where you see credits and debits. So usually people assume transactions to be only like the credit and debit of funds. Ideally, anything which is going to be updated on the ledger is a transaction. Even a message, sending a message along with money or whatever, it's a transaction. So it is in such a manner that it is connected via a linked list of blocks. Now, each and every block in each and every chain, please remember this when I'll repeat it a couple of times. Each and every chain has their own set of style of computing or calculating a block, okay? Combining various transactions in a single block. Now, you guys would be hearing that Ethereum takes around 15 to 20 seconds in order to finalize a block. Polkadot takes around 6 seconds to finalize a block. We will cover this in detail, what does finalization means and what does generation of a block means. And so all of these transactions, when they are combined together into an ordered set, they go inside a single block. Now, each and every block which is linked from one block to another block, they form a chain, and hence blockchain. Okay. Now, blockchains are ideally very good at interacting with data, which is currently stored on them, because a lot of people by default, by definition, assume or understand that it's a database. Ideally, yes, it is a database, but it is not a database which could be able to store heavy amount of data, because that takes a lot of computation and it makes your chain really expensive. So this is a concept about a single blockchain. Now, in order to have a communication or a channel from one blockchain to another blockchain, it is not currently easy yet. That is the reason you guys would be hearing a lot about bridges over the period of time. Because see, when if you have to communicate from one application to another application, so you need APIs in order to make that call, to send or receive any kind of request. I'm sure a lot of people would be front-end developers, so HTTPS request that you guys would be putting it on from your database, right? So these are the API calls that you ideally make. Similarly, from one blockchain to another blockchain, it is currently very difficult. So what came as a solution? Okay, before we go into that, I just wanted to understand, since you guys have already started picking up on Rust. So a small question, how many of you are aware of this answer? Like, what all blockchains are developing on Rust at the moment? Can we take a quick poll around it? Probably you can put your answer on the chat, A, B, C, or D. Let's see. You guys have quick 10 seconds, and then we'll go to the next slide.
So the answer that we are getting from most of them is all of the above.
Oh, that's nice. That's nice. Like, people are already aware of the capabilities that Rust is offering. So yeah, answer is all of the above. Now, earlier I was telling you about that issue, the communication between various blockchains. So that is a solution which Polkadot has come up with, right? So this was one of the issue. So Polkadot came up with a concept known as parachains. We'll go into that also in detail. So any network which is built on top of Polkadot will be able to communicate on any other network which is part of the Polkadot ecosystem. Okay, this way they are able to serve on generalized and also specialized blockchains. Okay, and these are able to communicate using a protocol known as XCMP. Okay, that is known as cross-chain messaging protocol. This automatically helps them scale or become bigger in comparison to other single layered blockchains. Okay, now when I said generalized and specialized blockchain, so these are known as custom made platforms. Okay, and also since this is purely written in Rust, so you can create a binary out of it, and the moment you create a binary out of it, so then they call it as WASM. Polkadot came up with a concept of actually kind of having a forkless upgrade. So I'm sure you guys would have heard a lot about this fork happened, that fork happened, so the chain breaks, right, because of the hacks. In the Polkadot, the moment, see, at the end of the day, it's basically a software, right? Any bug can be found or any feature could be generated at any period of time, over the period of time, right? But for that, you don't need to fork the chain, right? Now, in order to mitigate that issue, they came up with a forkless upgrade kind of a concept, which we will cover. Now, just a small definition. Polkadot is a next generation blockchain protocol that unites an entire network of purpose-built blockchains. Okay, now we'll just quickly understand these words. What are parachains, collators, validators, and nominators? Just remember these four words: parachains, collators, validators, and nominators. I'll try to explain you from this particular diagram. Okay, let me know if you're able to see my mouse. Just give a yes if you're able to see my mouse. Okay, I assume you guys are able to see my mouse moving.
Yes,
okay.
We heard yes from the crowd.
Okay, so this silver ring that you see, this silver ring, this is nothing but your Polkadot relay chain. Okay, now I'm sure you guys are from college at the moment, so you guys will be aware of relay race, right? One user, one runner basically passes the baton to the another runner, and that second baton is being passed from second runner to the third runner. So all of these runners are basically running to the final finish line, right? Now when they finally finish to the final point, right, then the relay race completes. So when all of these particular elements, I'll explain what are these elements. when all of these elements are running to the final point, they come to this chain. This is known as relay chain, and this relay chain is nothing but polka dot. Okay, this relay chain is nothing but polka dot. Now these small squares that you see, these are known as slots. SLOTS, slots. Each and every slot is attached to the relay chain via this particular slot or this particular triangle. This triangle that you see, this is nothing but a para chain. Okay, para chain, parallel chain, para chain 1, para chain 2, para chain 3, para chain 4, para chain 10, para chain 20. Similarly, there are 100 para chains that can work in parallel on a single relay chain, only on the single relay chain, which is polka dot. Okay, is it okay up till now? If you guys are able to understand this diagram the way I am trying to explain, I'm sure you guys would be very clear with the polka dot ecosystem overall. So if you have any questions, we'll cover it, but please make a note of all of those questions right now itself, so that when we finish the overall talk, so you can ask me these questions. So this particular slot that I was saying, this is nothing but a para chain. Now these small pink dots that you see on top of that, these are nothing but your collators. Now these collators are nothing but the nodes as in computers, right? So every chain is supported by certain nodes. Now basically the distributed ledger that we were talking about, right, and the transactions that we were talking about, those are getting executed and processed on a machine, right? So these collators, this is just a term given to these nodes, collators, right, which are actually running your para chain. But they don't have the authority to finalize the block, but they do have the authority to collect the transactions, put these transactions together into a single block, and pass this block, passing the baton as a runner from this to the relay chain. So basically taking the transactions from all of these collators and putting it into this chain via these nodes. Now these nodes are known as validators. Okay. Now so basically your para chain is attached to the relay chain via these validators, but these collators are basically collecting the blocks and passing to this validator, so that these validators can validate that whatever is coming from this chain, is it correct or not. Okay. Once they approve that yes, this particular block that is coming from this para chain is correct, they take it and they put it on this relay chain. Then it gets consumed over here. Now anybody in the network who is associated to this relay chain can actually call, so we call it as storages, or the transactions, can see and verify whether the transaction that was added or the block that was added or the storage that has been updated, is it correct or not, right? So this is how the transparency is maintained on this relay chain. Now, earlier I also mentioned that by default, blockchains do not provide this option of intercommunication. Like from one blockchain to another blockchain, there is still an issue like communication. One blockchain is not able to have a proper conversation with another blockchain that, okay, listen, I have this NFT on my chain. Can I go ahead and mint the same NFT on your chain? No, it is currently not that easy, but as we speak, there are a lot of development going around that ecosystem known as bridging. So we are able to port the NFTs as well. We'll go into that in detail later. Now coming to this point, so when I explained about intercommunication, so basically now this parachain, if this parachain 1 wants to communicate with this parachain 10, let's assume this is parachain 10, so they can directly communicate via this relay chain. So this parachain would send a message to this relay chain. Validator will actually validate whether this particular change needs to happen or not. He would actually pass it from this to this and give it to this. So this is, So this is how the overall intercommunication using cross-chain messaging protocol ideally works in parachain. Okay. Now, as I promised, I would cover these 4 points only by the diagram itself. So parachains, collators, validators. Now the 4th point is nominators. Nominators you can't see in this diagram, but I'll give you a brief understanding. So validator is going to validate the blocks, but validators do need certain funds. I'm sure you guys would have already understood how Bitcoin works and how Ethereum works. So Ethereum works on the concept of proof of stake now after merge 2.0. Earlier it was used to be proof of work. So we will talk about proof of stake. Now in order to be a part of the ecosystem, okay, or be a part of the chain, you need to stake certain funds. When I say certain funds, certain tokens that you have bought, okay, onto that network. That, okay, I want to have a vote, I want to have the authority, I want to be the part of the ecosystem. So you start staking, right? Now based on this stake, you can become a validator, okay, so that you can get funds, so that you can help in generating and finalizing the block, and also earn rewards because you are definitely providing your compute as well, right? So there are a set of people who want to earn on top of these validators, right? So there you can assume those like to be silent investors who are actually nominating that, okay, I want to nominate, okay, my name is Varun, there could be another person as Rahul. So there is one validator as Varun, the another validator as Rahul on the ecosystem or on the platform. So nominator A wants to decide that I want to, kind of put my funds on Varun or Rahul. So then based on that, based on the previous transactions that I have done, and based on my previous feedback that I have been receiving overall on the ecosystem, that person ideally is going to decide that I want to put my funds with Varun or with Rahul. Because Varun might give me 15% extra or Rahul might give me 10% less, whatever the number is, right? All of this as an information is available on Polkadot portal itself. So you can basically decide on that. So these are the people who are just going to put some funds in order to return some extra passive income, okay, and also be part of the ecosystem. So these are known as nominators. If you have any questions at the moment, so I don't know, can we take it now, or should we move forward?
Yes? Yes, Varun.
Should we move forward?
Yes, absolutely.
All right. So this is the idea about Polkadot, parachain, relay chain, non-escalators, and validators. Now, this word you would be hearing a lot going forward. Probably the next 5 to 6 days would be all about substrate. So substrate is ideally very simple. It has been created in such a manner that it's very complex. Ideally, it is not. Once you understand how Rust programming works, you will end up enjoying writing code in Substrate also. So Substrate is basically a framework which is provided by Parity team. Parity is the team which has written the software Polkadot. Okay. So they have also created a framework for anybody to actually download it from GitHub. Okay. So you guys would be cloning this entire repo, okay, repository into your local machine, and you would be making certain changes, but 90% of the code remains the same, okay? Only 10%, not even 10%, around 7 to 8% is the place where you will be making certain changes to make a customized blockchain. When I say customized blockchain, now earlier Sneha mentioned about Nitro network, right? Nitro network is a custom chain which is offering a custom solution, right? Similarly, if I want to have my own blockchain doing something different than what Ethereum is doing, than what Near is doing, than what Cosmos, so I can actually clone this entire repository, Substrate framework, and I can make few changes rather than, kind of making changes into the entire code base. So this is the overall framework that they have given. So I've already covered what is Substrate and why do we really need Substrate. Why do we really need Substrate is for quick hacking. Basically, the go-to-market strategies keep changing on a daily basis these days, right? So you don't want to invest too much of your time into development also. So that is the reason people end up using these frameworks where everything is an automated solution or a software already created with only few limited changes that you can actually provide. Okay, so Substrate uses a term known as frame. Okay, frame is the framework for runtime aggregation and modularized entities. Just forget about this overall long game, but just remember this word frame. Okay, Substrate provide you a package. Okay, in that package, so basically a library. Frame is a library. In that frame library, there are around 50 to 60 packages already pre-written, pre-compiled, so that you can automatically just add that one line. I'll show you how to add that one line as well. That will bring all the functions, all the traits, all the features which are already part of that package. Okay, you just need to include that line. Okay. Now, let's actually, so these are 4 things that we will be covering. What are palettes, runtime, node, frame, crates. But let's actually go to substrate node template itself. I already have it open. So earlier I mentioned to you, right, that you can go ahead and directly clone this repository. This is an open source package which is currently available by Parity team itself. So you can directly go ahead and clone it. Okay. The moment you clone it, you will get all of these packages combined together. Okay. Now, inside every library, so just assume that this substrate node template that we are seeing, it's a template which is a library in itself, which has various pre-compiled packages already written inside. Okay. Now, one thing is that you can create your own custom palette. So in Ethereum, you call it as smart contracts, right? That you would be writing a smart contract. Similarly, over here, you would be writing a palette. Okay, so you need to add that palette. We will cover that. Okay, let's go to palettes template. So this is a template palette that you need to add, or you need to customize, or you need to add. Okay. Okay. Now over here, I was telling you that there is something known as frame. Frame by default provides you pre-compiled packages written. So see, this is the dependency that you are going to add over here, frame support and frame system. This is currently at 0.9.35 version. So the moment you add this particular line, frame support and frame system, you know what will happen? Let's actually go ahead and copy this link. I'm trying to have it more so that you can understand that what basically is happening. Because this will definitely help you the moment you start coding on it, because at the end of the day, you guys are supposed to code on this. Now, I told you, right, remember this word frame, don't worry about the overall definition of frame. Inside frame, these are all the pre-compiled packages, right? You don't have to write any of these packages, you just need to include this particular line. Now the moment you actually include this particular line, by default it will provide you all of these packages which are part of frame. Alliances, assets, atomic swap. I'm sure everybody would understand based on Solidity, like what our balances are. So let's go ahead and understand in balances if I have to include that, right? So what does balance actually provides me, right? So I was telling you about functions, right? So over here the functions are ideally called as call. They have updated it to runtime call. So see, this is a pre-compiled code already written for you. This is the beauty of Substrate framework. You don't have to write transfer function from scratch anymore, right? The moment you call balances and then balances ka transfer function, so you just need to provide to from how much. See, okay, from to how much, transfer, right? So ideally, in any of the languages that you are going to work on, you need to create these functions, right? You need to compile these functions separately. You need to resolve the dependencies that are coming along with it. Over here, when I talk about Substrate framework, which is providing you frame, you don't have to write any of this. You just need to import them. And I told you how to import that, just add it into a line as a dependency, right? Now, this goes into your, so I do want to ask one small question. Who is managing, who is currently on call with me?
Varun, can you repeat the question, please?
Who have we already covered by any chance about cargo, substrate, or Rust at all?
No, Varun, not yet.
Okay, not yet. So guys, the way I'm trying to explain it to you, the moment you guys go through the entire hackathon. So you will understand from where am I coming and what am I trying to say. Right now, when you're listening it for the first time, it might slightly bounce off that what is he even talking about. But trust me, the moment the mentors are going to explain it to you that how each and everything works, you will understand that, okay, Varun was this guy who tried to explain us this, now it is actually fitting in. Okay. So basically you add these particular functionalities, transfer like from, to, and value. So this is how frame overall works, right? Let me go back to the deck again. So I told you about palettes, right? So these are nothing but your custom logic. Okay, custom logic, basically your smart contracts are known as palettes in Substrate, right? Now, whenever you are going to compile a code, then you are going to create a package, right? You need to tell Substrate or your blockchain node that, okay, listen, I have created this smart contract which is around balances. Varun wants to transfer funds to Rahul, right? So can you add this particular function into the node? Can you add this particular into the node? But at that particular time, Cargo is basically a package manager which helps you compile the code in Rust. Okay, Cargo will say that, okay, in order to add it into the node, you need to add first into a runtime. Because see, whatever you are going to tell me, by the way, this is the talk that Node is having with me at the moment. Okay, so Node is saying that, okay, whatever you want to add, first you need to add into runtime. Because see, I am not sure how many runtimes you are going to have. Now you can have one runtime, you can have two runtimes, you can have three runtimes. So whichever runtime you want me to add, you will be adding that into my node. I'll show you where you are going to add it. But the custom logic that you need to add, now this custom logic will go into runtime. This is the overall flow. Okay, in order to create your blockchain from scratch using Substrate framework, you add a palette, you add that palette into runtime. Sorry, you create a palette, you add that palette into runtime. Now this runtime you add into node. When these three things are combined together, you just write one line on your terminal, your blockchain is ready. I'll show you how. So you understood, right, from where balances was coming, frame system. Okay. Now the moment you go to this template again, okay, I'll walk you through this again. So as I said, create a new palette, add into your runtime, then add your runtime into the node. Let's go to this. Okay. So there is a palette known as palette template. This is the name of the palette template. And how do you decide the name of the palette? Whatever name you are mentioning over here in your cargo.toml, this is your name of the palette, basically your package. Now the moment you come outside, okay, this palette you created, you go into the runtime. Okay, inside runtime, there is a file known as lib.rs. Okay, now I'll show you. See, it is automatically written, configure the palette template in palettes template. It is so easy, it is so verbose that it automatically tells you what to put and where to put. Now there is a macro known as construct runtime. So by default, Substrate is telling you that I want to create a runtime using all of these packages. My package, my overall library, whatever I am going to run, should contain all of these packages which are available by default. But I want you to include my logic also, my custom logic, which is template. Okay, you can have your own name, whatever you want to customize. Okay, the moment you mention whatever your name is, it creates an instance of that template module. Okay, now this you have added into your runtime. Now let's actually come to this. Okay, now in your runtime, as I said, the names, what you are deciding as the name, goes into cargo.toml. So this runtime that you have, node template runtime, you are going to add this node template runtime into your node. Okay, so let's go to source and change spec.rs. Okay, see, we copied the name node template runtime. That is the name of your runtime. You see this node template runtime over here. Now what we are saying to the node, basically the computer who is going to run this entire software or the package, that I have created my custom logic as palette template. That palette template I have added into a runtime. Now I am adding that runtime into this node. So whenever you are going to compile, by default, it will contain all of these configurations along with my custom configuration also, which is template, the palette template that we added, right? All of that goes inside here. So this I'm sure you will get covered in detail, but this is how the overall Polkadot ecosystem works or substrate framework works. Okay. Now I want to have it open as a conversation. Wherever you guys are stuck, let's have that conversation and understand what you didn't understand and where I can go in detail. So I'll stop sharing, or if you guys want me to share again, I can share again. Or did it like completely bounce off?
I don't think so. We have actually covered it very nicely, but I would still want to know if there are any questions among the students, if they have noted down or if there's any doubt. Yeah, we have a doubt. 1 second. Hi, Varun.
Okay. I would also like give you a small. Yeah. Hi.
So my basic question was like, what's the main purpose of interaction between one block to another block?
One blockchain to another blockchain or one block to another block?
Yeah, what's the main purpose of interaction between one blockchain to another blockchain in Polkadot?
Okay, see, the overall idea is that we want to scale the overall ecosystem, right? When I say scaling, currently what happens is there are very limited number of transactions that you can do in a single second or in a single block. Now, because see, it's a decentralized method, right? Now, when we are talking about scalability and having that scalability along with proper transparency, so let me do one thing. I'll give you a small demo. I'll cover that question of yours. I'll just share my screen once again. Let me know once you're able to see my screen.
Yeah, we can.
Okay. My network is slightly slow, so bear with me. So see, we will be coming to this first and switch. So this is where you would be actually testing your application end to end. This is known as Polkadot.js portal, or you can call it as Polkadot.js apps. Now, if you are able to see my screen, so on the left hand side there is a triangle over here. I am able to select, okay, various chains which are already live on this ecosystem. So this is known as Polkadot and parachains. Now inside Polkadot, okay, these are the various parachains. What happens is, comes to transfer something to Arjuna, okay, transfer a message or transfer a token or transfer some funds which are common across. So Akala will ideally just send via one transaction to Arjuna without paying any fee. So what happens is when you are transferring any block or any transaction from one chain to another chain, you have to pay a really heavy fee. Not only heavy fee, you also need to understand in which root language that particular ecosystem is written in. Now, for example, Substrate, okay, this is a Rust-based environment. They don't have a separate virtual machine created. In Ethereum, you would have heard a lot about EVM, Ethereum Virtual Machine. They have their own set of writing a block and then finalizing a block. They have their own structure, right? They have their own format. Similarly, Substrate has their own format, which you will learn, right? Now, when any particular chain wants to have a conversation with any other chain, they need to understand their language, right? That what are they even talking about? What is the format? What 160 bits to 256 bits conversion? How is it going to happen? Similarly, we need to understand that, correct? Now, in order to make it easy, okay, Akala and Arjuna, they have a base 256 bits already created, kind of a format which is provided by Substrate. So anything which is part of this ecosystem Okay? When they transfer from this to this, it automatically scales various transactions across the overall network. Right? Now, coming back to your main point, I'll just come over here. So see, at the moment on the ecosystem, there are 36 parachains. So that simply means 36 networks can talk to each other without paying any heavy fee, without kind of doing any conversions. When I say conversions, without any adopting to any kind of a format or any kind of code writing style. I just called one function from here to another function on the other chain. It automatically does via the relay chain. So what happens is there are too many transactions happening at parallel. This is not possible on other chain at the moment. Does that answer your question? So if I have to send from Akala to Moonbeam, I just need to provide this ID, para ID, that I want to send funds from this para ID to this para ID, 2000 to 2004, Varun to Rahul. Now Rahul is an account which is a global account, basically a substrate based account. Similarly, there are Ethereum accounts, right? Wallet addresses. So there is a single wallet address created across all of these parachains. They would be using a single wallet address, basically, if I have to transfer anything.
Yep, so we have the nod that he has understood. Any other questions we have here? Yeah. Yeah, we have another question, Varun, one second.
Sure.
Hi, sir.
Hello.
Sir, you have mentioned a term called nominators. Sorry?
Yeah, that's correct. Nominators, yeah.
Nominators are the kind of persons like they don't have enough time so that they can earn some passive money by dedicating the fund that they have to the validators. Is that the thing, sir?
That's correct. That's correct. You are able to see my screen?
I'm sorry?
Are you able to see my screen right now?
Yes, sir.
Okay, it is still loading. So you see by default there are certain tabs created over here. So there would be a set of validators who are actually validating a block, right? Who are actually completing the block.
Yeah.
Similarly, there are set of nominators over here, active nominators.
Okay.
Right? So out of these 297 active validators, okay, if I want to become a nominator, I'm going to stake my funds and put my money on any of these validators.
Okay.
Okay.
But sir, how a person who is funding his money can trust a particular validator? Like he may run away with some mischievous deed within the for every transaction, for every right transaction he does, he will be receiving some profit, and that profit will be split across the investor and him and he himself. What if he does some mischievous deed I'm not exactly.
No, I totally get your question, and I'll quickly cover that. See, there is a concept of slashing, SLASH, right?
Okay.
Now, if any validator is going to misbehave, or if is going to take money and run away, right? Yeah. All the tokens firstly would be lost because they are currently locked into a contract known as escrow.
Yeah.
Okay, they are bonded. So validators tokens are also bonded with Polkadot.
Okay.
Right, into a particular pool that is known as a validator pool. They have to give certain funds. In order to mitigate these sort of issues, because see, nominator is going to nominate the validator, he is also going to put his funds onto that particular pool. Now, if the validator is going to misbehave, most of the tokens will be swiped off.
Okay.
So that way you are making sure that nominator is not at the receiving end.
Okay, sir.
Okay, so this is how you mitigate by slashing.
Okay. Got it, sir. Yes, sir, slashing. Yeah. Thank you, sir.
Sure.
Thanks, Varun. Guys, any other questions? Yeah. Varun, we have another question. Just a sec.
Sure.
So,
in the previous example, you have mentioned that there are 36 parachains of 11 parathreads. So in a network, what factor determines that how many parachains should present? Parachains or parathreads?
Yeah, this is a call taken by Polkadot ecosystem themselves. There are certain benchmarking that ecosystem does. It will not affect the transaction time, that how much transaction time it is going to take if everybody is just validating if too many parachains are running. It should not bloat the overall relation also. So they themselves have come up with a number as 100. Maximum they are going to run 100 parachains. Out of that, currently they already have onboarded 36 parachains, basically 36 networks running in parallel. So they themselves select. So if you want to be a parachain, there is an auction period which happens on Polkadot ecosystem. So you have to participate in auction, and then you have to present that, okay, this is the utility or this is the use case that I am going to create as a parachain. I am going to add this utility onto your ecosystem. If they approve, based on that, only then you will become a parachain. And then there is a lease period. So you are basically leasing the property from them. That, okay, I showed you slots earlier, right? Those small rectangles, those are the slots. So those slots currently are only 100. So in order to be actively participating in the ecosystem, you need to lease that particular slot.
Okay, thank you.
Does that answer your question?
Yes, sir.
Okay.
Yeah, thanks. Any other questions? Guys, as I've said it before. Hello. Yeah, as I've said it before, no question is a stupid question. So, I mean, our mentors, speakers will obviously go back to doing what they were doing. They work on some amazing things. But for you to do that, you'll definitely need to, be better at what we are doing here. So make sure if there are any questions, you come and ask it. Do not be shy. We are all here to learn. If we'll make mistakes, then we'll learn better, right? So we can proceed? All right, so Varun, I guess, is there anything else you would like to add before we come to the closing comments?
No, I am good. I just want them to hack more around Substrate. This is definitely one of the most promising frameworks that I have worked on over years. And I tried to give you a brief, slight introduction how Substrate overall works. But I'm sure Silva sir will cover this in detail. Blockchain as well.
Yeah, absolutely. Guys, a huge round of applause to Mr. Varun Gyanchantani. Varun, thank you once again for joining us. We hope to see you soon.
Thank you so much for having me. Thank you guys. All the best.
Thank you so much. Yeah, so my colleague Shweta here will discuss with you some important things. Please go.
Yeah, good afternoon guys. Okay, echo time తీసుకోను. So we already know we have some Web3 volunteers here. We have who come up on Saturday. So can you guys please stand up? Okay. Today, I'll be sharing some Google Forms with these people. These people will approach you with this. So please cooperate with them. If you have any doubts, please reach out to them. And you guys, if you have any doubts, please reach out to me. And also, to create a broadcast channel amongst yourself. So we have a QR code here. So everyone please scan and then join that group to make a easy communication amongst yourself. Glum task thing. I'll show you one more QR code for the Glum task.
guys, you have like a few minutes, like a minute to scan it. I don't think it should take time. Please do it quickly so we can move on to the next. How many of you have already scanned and joined? Raise your hand. How many of you are still in the process? Raise your hand. Okay. Anyone facing any particular issue? Raise your hand. Anyone is having any issue? No, right? Anyone needs the scan code here, or we can move to the next scan? We all have scanned, right? Anyone who hasn't scanned it? Yeah, okay. Please scan. Those who haven't scanned, basically, see, you can take it once your friends join the group. You can obviously take the invite and then move ahead. All right. So there's another. Yeah, Shweta, you want to address?
Yeah, so hope everyone joined the WhatsApp group. So here this QR code, it leads to a GLIM platform where రోజు మీకు కొన్ని టాస్క్ అసైన్ అవుతాయి దాంట్లో. సో whenever you complete a task, దానికి పక్కన పాయింట్స్ కూడా ఉంటాయి, పాయింట్స్ కూడా యాడ్ అవుతాయి. సో ఈ రోజు మీరు ఇది స్కాన్ చేస్తే మీకు కొన్ని టాస్క్స్ కనిపిస్తాయి. అండ్ టుమారో మార్నింగ్ దిస్ పర్సన్ GLIM task. Yeah, so he'll come up with a dashboard, which is an auto-generated dashboard. So we'll address the top 10 people in that dashboard. So, and I especially want to mention this guy Gopi Reddy, who already invited 56 people onto Discord, IBC Discord. Please give it up to him.
Do we have Mr. Gopi here?
Who is Gopi Reddy?
Gopi Reddy is a ghost. He is walking under the shadows.
So అందరూ ఇది స్కాన్ చేయండి and I'll share it again in the group. Please make sure you guys complete the tasks on daily basis and you make sure everyone does that. Okay?
All right, guys, we'll keep the scan code on for now. And please, Sweta, I think they can sit, right? Yeah, guys, we can sit down. Thank you so much. All right, so we'll move on to the next session, the most important session of the day, which is the lunch session. And right now it's, I think, 1:20. So, before that, just a second. Yeah, we'll reach there. Before that, I would like Praveen sir to just address some important things.
Yeah. So I'll not take a lot of time before we break for lunch, Guys, please. Hello. All of you, please. I just wanted to make some connection between what you attended just now and what we have been talking earlier, right? So we talked about different islands of different blockchains, all having their own convention systems, everything, correct? Now, what really is happening that there are bridges being formed. Now, through these bridges, assets and tokens and all these things are being transported between the different chains. Guys, please give me 2 minutes. I'll not hold you from lunch. But understand this point, it's very important. So, excuse me there, please. So now what is happening that all these interactions are happening by different bridges. Okay, now
what is happening, the problem in that is that everybody is coming up with a bridge. Okay, everybody is coming up with a bridge. Now these bridges have become places where a lot of exploits are happening. Because if you don't make a bridge perfectly, your token will disappear. Because there are a lot of thefts happening in the smart contracts. And that has been one of the biggest problems of blockchain world is the interoperability is not there. And if you look at the Polkadot ecosystem that Varun talked about and what he was explaining, that's perfectly the solution for that. What they have done, in the center you saw that was a relay chain. That is the hub. It's hub and spoke kind of model, right? And all the different chains or applications which are there as parachains. Now these parachains can talk to each other going via the relay chain. That is the crux of the solution. Okay, and Polkadot has already built the solution, and that is where they call themselves as layer 0, which is one layer below layer 1, where they are enabling these layer 1s to talk to each other. Okay, now there are a lot of technicalities that you will understand. Even Selva sir will cover a lot of things today. We are going to be, just after lunch, we are going to be having a session from Urban. You saw Urban earlier? Day 1 from the Web3 Foundation. He is going to be talking about just after lunch on the different functional things which have been built on Polkadot. Okay, that will be a very interesting session, and post that Selva sir will get deeper into the technology. But I am trying to set the context. The concept is same here as well. You have validators who are building, who are doing the blocks, who are validating by means of staking. I mean, they are putting their money at a stake, that he talked about bonding, right? Concept is same. But the implementation has been done in a different way to achieve very specific purpose. Are you guys connecting with me, what I'm saying? That's exactly what I'm talking about. If you understand the basics, what we have been talking about for the last 3 days, you can get mastery into any blockchain. Nothing is going to be completely different. So just focus on the fundamentals. Okay, and now enjoy your lunch. Okay, thank you.
And guys, we'll be reconvening at 1:45. Okay, 2:15. At 2:15, guys, 45 minutes. It's more than enough.
Mini auditorium lo lunch sir. Mini auditorium we arrange lunch sir. So go through the first floor corridor from the left.
Guys, go through the first floor corridor. In the mini auditorium, the lunch has been arranged, and our volunteers will be guiding you on the way as well. Guys, why are so many seats empty? Where are other students? Guys, if some of your friends are outside, please call them immediately.
Urban join.
Guys, let's settle in. We'll begin now. I'm still not able to figure out why other students have not come yet. Have they left? Then, guys, 1 hour for 15 minutes. I mean, that's just too much, no? Can you guys call if you are aware?
Good afternoon, guys. Okay, so guys, let's maintain the silence. So we have with us Urban Oswald from Web3 Foundation. I'm sure you have heard him on day one. So Urban comes with rich experience and background in blockchain, and he is going to be talking to us today on the Polkadot functional ecosystem. Now, you all have understood so far that blockchain can do several things, and especially with respect to the different types of applications which are being built on blockchain, there are so many of them. And as you also know, that Polkadot being a layer 0 protocol, it enables different parachains to interact with each other, and all these parachains represent various different types of businesses. So without further ado, let me introduce you Urban Oswald. Please give him a wide round of applause.
Thank you very much. All right, I think this is my cue then. Just let me know if I'm not audible or visible or anything like that. But anyways, thank you very much for the warm introduction. Like said, my name is Urban. I am currently at the Web3 Foundation. And you've probably seen me give you kind of an introductory keynote, but today I'm actually jumping in for my colleague Ray, who unfortunately can't be here today, but she usually gives a very good overview of what the Polkadot ecosystem looks like and feels like, and who's in it, and what they're building, hence the title Polkadot Functional Ecosystem. So with that said, let's dive right in. Now, before we go into any kind of details, I wanted to highlight that Polkadot is actually one of the largest blockchain ecosystems out there, at least in terms of pure people that are working on it. So how many engineers, how many developers are building applications on top or for Polkadot? Here you see two charts that I've pulled up. One is from Token Terminal, the other one is from Electric Capital. Now, Token Terminal is surely just showing you how many devs are working on Polkadot and associated repos, whereas the Electric Capital is kind of bringing out a comparison between primarily Ethereum and the others. And you see that Polkadot is kind of the second largest developer ecosystem out there, which is fantastic, especially if you think about when it actually launched. So all of these blockchain technologies are fairly new, right? We're not talking about decades of engineering or hundreds of years of engineering going into them. It's really just a handful of years that this has been going on. And as you can see, Ethereum was the first kind of smart contracting blockchain out there, which really enabled the existence of any kind of ecosystem for developers. Because on top of Bitcoin, which is one of the predecessors from Ethereum, you really couldn't do much on top of it, right? You could use the chain and everything, but you really weren't able to build something on top of it, which changed with Ethereum. Now, Polkadot is kind of this next generation blockchain that enables to do this, and we see that purely in terms of raw numbers, how many people are developing on there, Polkadot as an ecosystem is doing pretty well. I've heard during my introduction, people say, parachains and Polkadot and Layer 0 and so on. So before we go into more details, I just wanted to take a step back and highlight this this graphic for you. And you've seen this at my other presentation if you were there. So Polkadot has a core relay chain as well as parachains, so specialized blockchains that connect back to parachain to its relay chain. The question is, why would you even have a setup like that? Well, why would you need this? Right? Now, the thing is that parachains or blockchains, if you look at them purely from a technical perspective, they're very much non-scalable. Right? There's very few knobs and levers that you can pull in order to scale them to accommodate for all the transactions, the throughput that you would actually need. Now, in order to get around that, the very smart people at Parity Technologies, as well as the Web3 Foundation, have come up with a system that enables this kind of scaling. So traditionally you would call this sharding. So all of these parachains are essentially shards, but shards in a traditional sense would basically mean that they're all the same. They mostly should be the same. Whereas here we call them heterogeneous shards, which means that they can accommodate for specific use cases. They can be tweaked and created and built in specific ways in order to accommodate specific use cases. So this whole system is secured by the Polkadot relay chain via a nominated proof of stake consensus mechanism. That just means that instead of having a lot of physical mining machines that would mine blocks like you have today still with the Bitcoin network, for instance, essentially participants within the ecosystem nominate their stake so that they secure the network. Now, this security also propagates onto its parachains, but the relay chain also allows message passing. So we call this cross-consensus messaging. It's a protocol that we use in here, so that parachain A can talk to parachain B, send assets, send messages, and whatever is needed. Now, I'm highlighting this just so that we have a base understanding of what we're going to be talking about going forward. Because there are multiple ways that you can build on top of Polkadot. And this is actually something very concrete that you guys are going to be discussing and looking at when you look at blockchains to build on. Usually what you would see with sort of smart contracting blockchains is that you can simply build on top of that chain using smart contracting languages. Now, in addition to that, obviously, you can build tooling and interfaces and experiences. The different part that you can do with Polkadot is to build out those chains as well. So I've mentioned this during my other presentation. If you have, for instance, a insurance example, right? You want to build something for the insurance industry, and you have a specific use case that needs tweaking on the bottom layer, which makes everything more efficient, more better. It's more optimized, and so on. You would opt for building a parachain. But you can also opt to build a smart contract on top of one of these chains, right? You can build tooling for some of these chains as well as for the relay chain, and you can build different interfaces. You can build wallets, fiat on and off ramps, bridges, whatever you want to do. But these are generally the 4 buckets within which you, as a builder, hacker, engineer, developer, you would be looking at Polkadot, right? Either you build a chain that ultimately can become a parachain. You would be building on top of a parachain, most likely using some sort of smart contracting language. Today we have Solidity compatibility as well as natively supported Ink. Ink is a Rust-based smart contracting language. You can also build tooling as well as the interfaces and experiences. So I'm kind of trying to double down on this explanation because I know it's really, really important for you going forward, right? What are some of the options that I can build with? And as you see, as we dive deeper into this presentation, these are actually the 4 buckets within which people are building. Now, we can't move forward without mentioning Kusama. Kusama is we call it the canary network. So it is a live network. It is, it's not a test net per se. It is incentivized. It's value bearing. You can go to, I don't know, CoinMarketCap or CoinGecko and look up the KSM prices and all of that. But the bottom line is that the tagline for Kusama really is expect chaos. And Kusama was launched before Polkadot launched. So the network of Polkadot launched on December 2020. Kusama launched before that. And the reason we have Kusama is to deploy early stage unaudited code to see if it can work. Right? But the thing is that Kusama really is a network on its own. So it has its own on-chain governance, which allows it to merge all of these things into itself. So it's not, as opposed to the early stages, it actually has evolved a little bit and diverged a little bit from the way Polkadot works. But in theory, different kinds of projects and teams and people use Kusama to deploy some of their early stage projects that they either migrate onto Polkadot or they have like a dual deployment setup. So it's a little bit different than what you've seen, for instance, within the Ethereum ecosystem or something like that. But Kusama is definitely a very important part of this whole Polkadot story. Now, I've mentioned parachains before, and before moving forward, I wanted to highlight where we are today, right? Because, like I said, Polkadot launched in 2020, in December 2020, and less than a year ago, we actually got the first parachains. So what does that mean, right? Because building a blockchain, as you can imagine, is not necessarily the easiest part. So we currently have 33 live parachains on Polkadot, and we have 41 on Kusama. So Kusama started this process a little bit earlier, so the teams can kind of start deploying, testing out, seeing how stuff works. There's also a number for crowd loans and auctions. As you can see, there's no live auction right now for Kusama, but there is a live auction on Polkadot, and it is the 35th auction. So that means that once that auction is done, we will get a new parachain that can be, let's say, attached to Polkadot's relay chain. There's only one crowd loan live, and crowd loans are basically a mechanism so that teams can bid on their slots. You need to bid on your slot, right? It is the same as if you would be a business and you would go to, for instance, the supermarket, and it has an empty store and you want to rent it out. You would not just be getting that, you would have to lease it, right? Which means that you are incentivized to actually do good business, to actually push yourself forward and to make a sustainable business out of it. It's the same principle here. Last thing that I want to mention, these parachain slots are up for 2 years, with obviously possible extensions and whatnot. That's all built in. But in order to do that, you need to lock in a certain amount of DOT, which gets returned back at the end of the slot. And currently we see there's 132 million DOT locked in, which would be 600 million in USD value equivalents today, which is kind of, it's very important, but ultimately if the price goes up or the price goes down, this number will fluctuate, whereas the number of DOT locked will not fluctuate. Cool. All right, so what does that mean in terms of pure numbers? Now, we track a fairly large amount of these projects. As you can see, we're at 543. My hunch is there's quite a few more that we just weren't able to catch, or maybe so early stage that we weren't even able to notice, and so on. So my assumption is this number is a little bit bigger. But you can see when we talk about what you can build, right? It's not just where you can build and using either a substrate to build the parachain or to build or with a smart contract and so on. You can see there's a whole plethora of different use cases ranging from infrastructure wallets to DeFi to NFTs. We've got different privacy solutions, zero knowledge proofs, for instance, if you've heard of them, it's a very hot topic, storage, smart contracting, and so on, right? So you see that there's a bunch of stuff being built across some of these use cases, but because we all like logos and graphics, this is a more, let's say, accurate depiction of what it looks like. So this map was not built by Parity or the Web3 Foundation. It's actually built by Subwallet, and you can view this on this link. It's called .insight.xyz. You can have a look at that and go through it. But you can see that there's, like I said, there's a range of different things that people are building. DeFi being quite a large bucket at this point. We've got DAOs, infrastructure, tooling, privacy is big. Like I said, we've got some teams working in IoT, smart contracts, and so on. So there's really a bunch of stuff that you can build. A few things that I would highlight is, for instance, storage, some of the natively available storage solutions, which, again, I really invite you to just pull up this website and click through some of these links. This one is from parachains.info. If you want to pull that up, parachains.info is a fantastic resource if you want to look at which are these parachains, how they function, and who they basically are. So, let's move on. What I wanted to show you here as well is a XCM dashboard, and I've showed you this in the keynote presentation as well. So look at Polkadot like a federated state, right? You've got your let's say if you look at Europe, right? You've got the European Union, and you've got all of these countries that get to talk to each other, to do business with each other, right? There's importing, exporting, there's communication, and so on. It's a good analogy to look at Polkadot as well. So Polkadot would be a whole ecosystem, like a continent, for instance. But you've got all of these kind of nation states or countries that are within that ecosystem, and they get to build infrastructure between each other. They get to build rails, they get to build roads, they get to build fiber optic cable, for instance, everything that you would need to work. And this is essentially what you're looking at. Right? So a lot of these are very early stage. General startups are early stage, but the whole ecosystem is very early stage. So you can see that over the last 30 days, 155,000 messages have been sent across, which, to be honest, I don't think that's a lot. But what you're going to see over the next years and so on is that there's going to be many more parachains that are interacting with each other. They're exporting and importing value. They're talking to each other. They're building together. Right? A very, very important kind of cornerstone of the Polkadot ecosystem is this ability that you deploy an application. If you build applications, end user applications, so that you can use a little bit. For instance, if you go back, you can use aspects from any parachain that's building something within DeFi, for instance, and you want to optimize your use case also for NFTs, right? And you see how you can bridge these two and build an application on top of it. You can pull in decentralized identity, right? You can pull in a lot of different things in order to construct a application that is really, that would not be possible within anywhere else, because you get this ecosystem of specialized blockchains. But again, what you're seeing here is actually, you remember the 4 buckets that I said, right? You've got the parachains, you've got the building a parachain, the smart contracts, the tooling, and the interfaces. This is essentially everything, right? So people keep on building on top of these ecosystems. The beauty of having Polkadot is not just having a chain and then you build on it. It's having an ecosystem of different chain solutions and people coming together, and then you build on top of that, or you build with them. Right? It's a very, very different value proposition than what we've seen in the past. So what you see here, again, you can go to polkadot.subscan.io/xcm_dashboard, or just go to subscan.io. You should be able to find this. And it gives you a very nice live view of what is happening. You can also scroll further down to view all of these transactions, who's been talking to each other the most, and so on. It's actually fascinating to see it in action. So one thing that I wanted to also mention or to highlight is that, and you've heard me use this word quite a couple of times, right? Parachains being built with Substrate. So Substrate is a blockchain building framework that really came from building Polkadot. Now, to give you a little bit of a kind of history lesson, back in 2016, 2017, Gavin Wood, which is currently the founder and the president of the Web3 Foundation, as well as the co-founder of Parity Technologies, was working at the Ethereum Foundation as its first chief technology officer. Right? And he was actually the guy who wrote the yellow paper, so the actual technical implementation of the Polkadot of the Ethereum white paper that Vitalik wrote back then. So he wrote the base code. He wrote what you today know as the Ethereum virtual machine and what you today know as Solidity, the programming language, right? And the idea behind Ethereum was, all right, let's kick it off. Let's have this one chain running and see how it goes. But simultaneously, let's start working on sort of a 2.0 implementation so that Ethereum can actually scale. Now, as things progressed and as time progressed, that just did not happen. And Gavin actually saw that very early on. And he was actually right. If you look at Ethereum, it just merged onto its 2.0 proof of stake network. So in the meantime, Gavin decided to leave the Ethereum Foundation and started working on Polkadot. There was an initial version of the white paper, and sort of technical implementation started to form. But as the engineers started to implement all of this, they noticed that it's going to be actually really hard for everybody to build this from scratch. So they need some sort of tool set. When people like yourself come into a hackathon, they can build something with it. When teams, companies come in, they don't have to build it from scratch. They can use a framework, an SDK essentially. And that is Substrate. So Substrate evolved and morphed into something almost on its own, which obviously highly contributes back to Polkadot. Polkadot and Kusama, as a matter of fact, are built with Substrate. So when you start using Substrate to build a parachain, if you opt to do that, you will be using the same toolset, the same code as Gavin and his team used to build Polkadot as well as Kusama. So Substrate in a nutshell is a modular framework that's very extensible, that allows you to build all of these parachains. It's got heaps of stuff that you can change, optimize. Generally, you're going to be working with Frame. Frame is the kind of modular part where you swap in and out different kinds of palettes. But this is the core of it, right? If you look at Polkadot from a technical perspective, this is essentially what you're looking at. Now, that's all good, right? But building blockchains is can be quite intimidating, and especially teams. We noticed early on that teams actually need support getting there, which is quite fun, right? So Parity built something, a program called the Substrate Builders Program. It's if you look at it, we tend to call it an evergreen accelerator. So it is a little bit more focused on the technical side, providing teams with kind of white glove support and engineering hours and so on. But generally, the Substrate Builders Program is really where some of the magic happens. A lot of teams, most of the teams, to my recollection, that currently have live parachains have gone through this program as well. And I think the program has, 70 plus right now active members that are building basically the next set of parachains. But we are currently, this is a little bit old, we're currently tracking 250 teams that are building something with Substrate, an actual parachain project. So there's a lot to come. The ecosystem will evolve, it will change. Some teams will unfortunately not make it, some will thrive. That's just the reality. But I'm very happy to see all of these teams coming in. And with all of these different kind of applications, different verticals opening up, different specialists coming in, obviously this is expanding more than ever. So one website that might be also very, very important for you, aside obviously from the technical documentation and everything, is called Square One. So if you go to substrate.io and look at, I think it's listed under opportunities, you're going to see this nice little, it's not even a dashboard, like it's a composition of different links, it's a repository. You can scroll through what is out there, and this is constantly being updated as new things come up. But for instance, education might be a very, very important part for you guys as well, if you're looking for, I don't know, maybe some online courses or stuff like that, community engagement, how to build staff development support, and so on. And so there's a lot out there to explore that is non-technical in nature. And I really, really implore you to have a look at this, because it can be quite the changing factor, so to say. Now, Polkadot also boasts a massive treasury. So you see me talk about the parachains and the crowd loans and slot auctions and all of that. But in all of that, I really didn't mention that Polkadot, the network, is a massive DAO. It's a huge, huge DAO that also has its own treasury. Because the idea is that you have on-chain governance, which allows you to make basically everybody who's a stakeholder within the Polkadot ecosystem can make a decision impacting Polkadot's future. That might be how to spend treasury funds. That might be how to upgrade certain parts of Polkadot crowd loans and so on, right? Now, in order to be able to implement some of these things, the network itself, the ecosystem, needs funding. Right? If you want to make updates and you need to hire a team to do some sort of upgrades, you need to pay that team. So the network, the DAO, really needs to have this mechanism built in. Now, I'm mentioning this because this is a huge pot of funds that can be used for both technical and non-technical things. And it's actually a very, very important stepping stone that a lot of companies use in order to make it. right? In order to get something funded. Mostly it's probably around common good stuff. So if you come in and say, I want to build this dApp, give me some dot, most likely it's not going to happen, right? But if you build something for the common good, for the chain, then that is absolutely gonna happen. So people have, funded meetups, events, hackathons. We've seen all of this stuff being funded through this as well. So a very, very important aspect when you dive in and you observe the ecosystem as well as some of the opportunities that are in there. So yeah, I'm sorry I mentioned this. It goes from technical to non-technical marketing hackathons as well as stuff that is beyond that. Now, one of the important things in the ecosystem are also Web3 Foundation grants. And actually, a lot of teams that go through hackathons are seeking some sort of follow-up funding. But maybe I've built some sort of tooling during the hackathon that's really important for the Polkadot ecosystem, and I don't want to just let it go, right? I would like to continue working on this. My team would like to continue working on this. Obviously not going to be doing this for free, right? So the Web3 Foundation has a extensive grants program. They have given out today over 500 grants. These can range from smaller, we call them Insta grants, up to large, basically there's unlimited funding if you need it, as well as maintenance grants. So let's say I develop some sort of infrastructure for the ecosystem that I want to keep maintaining. The Web3 Foundation can be paying you for this. Like I said, especially hackathon participants that wish to kind of take the next step with their project or continue keeping it alive and building on it and so on. This is a very, very important piece that's out there that you can essentially use, dive in, and make sure to utilize, if it makes sense, of course. Like I said, the foundation has given out over 500 grants, and this is kind of the composition. Now, we mostly give out grants for kind of runtime modules/chains, right? So maybe pallets, some of the development tooling, wallets, and some of the UI. Then you've got some smaller categories over there. One thing that I would mention that the Web3 Foundation does not give out grants for is non-technical stuff. So we wouldn't be funding meetups or hackathons or education, anything related to education essentially, and so on. The reason is not that they wouldn't want to, but the grants team is really a set of technical experts, right? And they just want to be doing what they do best, and there is currently no need to expand that because we have the Polkadot Treasury to cover some of these. One thing that I also want to mention that the Treasury does not really cover, although we have smart contracts on there, the team is not specialized in Solidity or any other smart contracting language than Ink, which is the native Rust-based smart contracting language. So just keep that in mind. If you apply for a grant with a dApp built on one of the parachains that supports Solidity and EVM, you want to continue building it, probably the Treasury is not the best resource for that, just because we don't have really good Solidity engineers. That's just the reality of it. But nonetheless, this is a very good resource to have. So with that, I'd like to wrap it up and say thank you for listening to me. Thank you for diving into the Polkadot ecosystem. I'd be happy to take any questions if there's anything like that. But aside from that, here's a few different kind of resources that you can look at as well, ranging from YouTubes to blogs to obviously the documentation, the wiki. There's email newsletters. There's, we are around if you go to the Polkadot Discord and you want to talk to some of us. We're all there. Don't be shy. Let us know what you need and what you're building and what you're interested in, what you're thinking, what you're learning. The community is large. The Polkadot Ambassador program on its own has over 2,000 members at this point. So there's a lot of stuff going on. Okay. Anyways, thank you very much. This is it from my side, and I'm happy to take some questions if there are any.
So Thank you, Arvind. Thank you so much for covering, things starting from the foundation and, the functional possibilities and the functional happenings on Polkadot. I'm sure students here have got a very good understanding of what really is happening on Polkadot right now, number one. And number two, also thank you for sharing the different programs that are right now active, which people can leverage to come and learn and build and, get some traction in terms of their application. So I think that was wonderful. Guys, so with all these information pieces, do you really have any question for Urban? Please feel free. I think Urban will be the, one of the persons you can ask questions anytime. I think so, Arvind. People don't seem to have questions, and just for your update, we have been, this is the 4th day of the program, and what we have been doing so far, we have been giving them, of course, the foundational knowledge of blockchain upon which they are building. We also had a session before in which we gave them a perspective of the Polkadot architecture in terms of how do these relay chains and parachains interact, and how do these collators and how do these validators work with each other, what is their roles. And I think they are getting into the shoes, and we have 4 more days program left, and I believe by the end of that we would have created some excellent Web3 developers.
Fantastic, that is great to hear. So I think you guys are doing a great job, and I'm very happy to see all of these students and everything. And I'd really like to bounce off of what you said, that I intentionally gave or highlighted a few of the opportunities in the ecosystem as well, because to me, looking at it from the outside, I actually see 543 potential employers. These are well-funded companies that are looking for engineering talent. Like, I can't put it more bluntly. This is probably one of the biggest opportunities in terms of, career advancements that you're going to see anywhere on the planet. And I'm not kidding, I'm part of that. All of us are, I'm employed by the Web3 Foundation, or I work for the Web3 Foundation. We've got Parity has 350 people working there. There's parachain teams, large and small. There's, you want to get a job, you will get a job here. That's just
absolutely.
as it gets. You want to get your company off the ground, you will be able to do that. So there's support mechanisms for everybody.
Absolutely, absolutely. So guys, I think you heard Urban. It is pretty clear. You have the skill, and if you have the skill, you have got it. I don't think there is anything else that really matters here. Right? So thank you, Urban. Thank you. Abhishek is not in today. He is busy into something else. And
thank you very much for having me. Enjoy and have a good day.
It's always a pleasure to have you. We always appreciate your insights. Thank you so much for joining us today, and we'll catch up sometime later. Thank you.
Thank you. Bye-bye.
Yeah, bye-bye.
Yeah, so we'll just take a few seconds, and we'll start with the next session, which will be taken by obviously Selva sir. And we'll just sort out the presentation, and then we'll begin. So first you will do. All right, guys. So now, obviously, we have Mr. C. Selvaraju, and he has spent the most amount of time with students in Alt Hack, Hyderabad. And there was a building phase that was also involved earlier. I mean, students hounded him most of the time to figure out issues that that they were facing while that process was happening. But fortunately / unfortunately, you might not get that opportunity offline, but he will definitely catch a lot of you online as well. Mr. Silva has had a very illustrious career. He has learned things all his life. He's still learning. Every day he spends a couple of hours ensuring that he learns, even if it's 3 a.m. in the morning, right? So you're going to hear from a person who has actually been in your shoes and still in your shoes by learning every day. So make sure you take the best out of him. Let's welcome Mr. Selvaraju. Ladies and gentlemen, I think I have woken everybody up, right? Okay, so I know, this is going to be another post-lunch torture session. You know, because after a sumptuous meal, it is not very easy to listen to someone, okay, blah, 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 blah. I'm also the same, you know, I also belong to the same category. Anyway, so, however, let's make this interesting, okay? So what I'm going to show you here is that, you know, now you know basics of Polkadot, okay? Now, one of the important things about Polkadot is that you have to think of Polkadot as a blockchain of blockchain or an internet of blockchains, okay? Now, the primary problem of any blockchain is that it's a closed system. It's a closed system. Like, for instance, let's say, I will take Bitcoin and Ethereum because the most popular blockchains. So I have Bitcoin or some asset on Bitcoin network. I want to transfer it to Ethereum network directly. I cannot do that. You cannot do that. Okay? Because fundamentally it's been designed like that you cannot transfer assets across these networks. So what they do, they put up bridges. We've already spoken about bridges, right? Now, one of the important things is, bridge is basically a workaround to achieve that. Okay?
So what happens with these bridges is that bridges actually bring in vulnerability into the system. And I'm telling you one very, very important thing, because this is a misconception that almost everybody tends to have, and that is, oh, this blockchain got hacked, that blockchain got hacked, this blockchain got hacked, all the time you'll be listening to things like that. The truth is, it is not the blockchain that gets hacked. Okay? On Ethereum, so many times it has happened. Or any EVM-based blockchains, so many things, so many times hacks have happened. Let me just clarify it to you. The blockchain is not hacked. Actually, you know what happens? The smart contracts have vulnerabilities which actually hackers tend to, exploit. So it is not the blockchain's fault. I wrote some code which is buggy code and which allows you to basically, transfer assets here and there, left and right, okay? So hackers find out a way, because you see, again, this is a transparent system in a sense that, suppose for instance on Ethereum, if I put up any smart contract, the entire world can see what is the code written there. Because transparency is part of the entire design. The whole point behind blockchain is the transparency. There's a big aspect of it. So if you're writing some code and you deploy it, what is the code that you deploy on a blockchain? What is the code that you deploy on a blockchain? Smart contract. Hey, don't talk about pallets. Okay, we'll come to that. So basically anything that a piece of code which runs on top of a blockchain is nothing but a smart contract. Okay? Now, when you deploy the smart contract, anybody can see the smart contract code. So the hackers are always on a lookout, okay? They keep looking at the smart contract, look for, vulnerabilities in the code, and that is what they exploit. That is what they exploit. So it is not the blockchain that is getting hacked. It is your code which is actually, giving them entry with all sorts of vulnerabilities. So this is something that you have to keep in mind. Nobody has hacked a blockchain, frankly speaking. No one has hacked a blockchain. Most of the times, whatever hacks have happened, the security breaches that have happened, they have happened at the smart contract level. Okay? Now, there's lots and lots of material out there for you to read upon in order to, master yourself in this blockchain domain. So your fundamentals need to be pretty clear. Go to Wikipedia, you will find, hundreds of pages talking about proof of work and proof of stake, okay, blockchain fundamentals, okay, decentralization, DeFi, CeFi, all those concepts are available. Start with there. Now, when it comes to development on Polkadot, so what Polkadot does is that it actually eliminates the whole point of bridges. It allows you essentially to connect directly to any blockchain, okay, to connect to the Polkadot's relay chain. So if you see, now this work has been going on for almost 4 to 5 years. And you know who is the founder of Polkadot? Gavin Wood, who was the co-founder of Ethereum, okay, who was the co-founder of Ethereum. So he knew ins and outs of the problems that Ethereum actually faces. And one of the most important problems that he found was that as the number of blockchains across the domain is growing, there are all kinds of blockchains are coming up. Communication between the blockchains became a big issue, and that is what Polkadot actually is actually trying to address that. Allowing the completely disparate, blockchains to talk to each other. Now, they also provide you with a complete SDK. Have you heard of the term SDK? Good. So, which allows you, okay, to actually build your own blockchain. Okay, that is what your substrate framework is. Okay, so substrate framework allows you to build your own custom blockchains. Because you see, when you want to build your own blockchain, Okay? You have to think about the consensus algorithm. You have to think about the security. You have to think about the block time. You have to think about this and that. Architecturally, each and every piece of the puzzle you have to solve. So what they have done is they have already done all the homework for you. Okay. So whatever pieces you want to build your own blockchain, you just take those pieces, which is what pallets are. You're talking about the pallets. So pallets are nothing but those pieces. A pallet for holding account balances, a pallet for actually, having your own consensus algorithm, a pallet for this thing, and so whatever you need. So think of it like, off-the-shelf components, you just pull them together and assemble it and build your own blockchain. Your own blockchain. And on top of it, you can do, and you can customize it the way you want it, and then build your blockchain, run it, and then you can put, if you want smart contract capabilities, you can put that also. Whatever you want, whatever application you can think of, you can build it with that. Now imagine if I were to build a blockchain all the way from scratch, I would have to, it will take me about a year to, finally write all the code and then you run it and then test it out, right? They have already given you with all the pieces of the puzzle. Fit them together and then build your own blockchain. I'm sorry. So, in order to do that, you need development environment setup, which is what we are going to see here. So, first thing first. Oh, thank you, sir. First thing first, everything in Polkadot is written in Rust. Okay? So, whether you like it or don't like it, you have to learn that programming language. Okay? That is one thing you have to keep in mind. The first thing you need is the Rust programming language knowledge. Again, remember, it is not difficult. It is no rocket science. You can learn that. It's quite similar to C, C++. But then again, the way Rust language has been designed is completely different from the way C and C++ does. So what this Rust language does is essentially, it's again a systems programming language. And remember, any systems programming language, okay, let's say, I'll just make a small divergence here. So if you, do you know Python? Okay, do you know C? Yes, which is easy? Why? Okay, modularity, inbuilt functions, what else? Flexible, readable, easy to read, more applications, okay? Right, now let me tell you, why Python is easy and C comparatively, okay, compared to C. Okay? Syntax, right? Okay, so basically, see, you have to understand. What was the purpose for which Python was designed? It was for application development. Okay? I'll come to the genesis of that also a little in a while. And what was the purpose of C language? Building operating systems. So it's primarily meant for system software. Any language that is designed to write system software is always difficult. That's the fundamental nature of any programming language that is designed for system software development. Lady, if you do not mind, can you keep your mobile inside? Or you can go outside and you can do all your social networking there. I would really appreciate it. Okay, so you have to remember, and another question, why is any system-oriented programming language difficult? That's because it's a language. See, all of you would have done any assembly programming? Done that? Okay, some of you have done that. Is it easy? You just cram those 10 lines of program and vomit in the exam and somehow pass it. Am I right? That's because, you see, truly speaking, if you want to really harness the power of the CPU, you should actually write the entire software in assembly only. But is it possible? Practically speaking, no. But remember, the first Unix was actually written for PDP-11 completely in assembly. The first Unix operating system was completely written in assembly. Okay? But it was found that, you cannot scale this up, right? So therefore you have to come up with a programming language which allows you to do that. So therefore this language, all the systems programming languages will be of lower level compared to application development languages. So they will have, all kinds of features like, pointers and references and all those things, okay, which basically seem difficult, but they are necessary to harness the power of your hardware so that your code runs as fast as possible. It's not it's not that you cannot write operating system in Python. People have written. But then the problem is, it will also run. But an operating system written in Python has to run with the Python bytecode, Python's interpreter. It will be inherently very slow. It will be inherently very slow. You cannot do anything about it. So similarly, whenever you see, you take embedded systems or you take real-time systems, they are all coded in C, C++ only. There is no language which is better at that, producing output which can run at the maximum possible speed. Because system software has to run at that speed, because there are situations where it can even lead to life and death situations. You might not probably realize. So in fact, see, for instance, you write an embedded system, okay, embedded system code, let's say for, heart rate monitoring machine, okay. So there is a heart rate monitoring machine which is looking at your heart rate, and if there is any erratic heartbeat, it immediately tells, indicates that, and then proper medical care can be provided to that patient. So you have an option, let's say, hypothetical situation again, you can write that in C and C++, embedded C, C++, or you can write it in Java. So you have built it both. Now imagine a situation where what is happening is that patient is having heart attack, okay? So his heartbeat is erratic. And at that point in time, Java's garbage collector runs. Okay? We always say garbage collector is the best thing in Java, right? You write an embedded software like that, and then the garbage collector runs when the patient is having heart attack. What will happen? Right? Isn't it? So, any application running on virtual machines have this issue. Okay? So what Rust has come up with is a solution. Now, C, C++, not that they are great, they have their own issues. You can leave dangling pointers out there and lead to all kinds of memory leaks, because you have to make heavy use of pointers. Heavy use of pointers. So therefore, memory leaks is a common issue. Common issue. So Rust has been designed to get rid of all of this. So what happens is in Rust, okay, you cannot have memory leaks. The compiler traces it and traps it at the compile time itself. Okay, but at the same time, because it's a systems programming language, it has got features in the language which make it a little difficult compared to other languages. But again, your while loop will look like the same while loop only. Okay, so if you know some programming language, porting over to Rust is not that difficult. The concepts in Rust which allow you to do powerful stuff like, macros and metaprogramming, okay, those are the things that actually take some amount of practice. Other than that, it's not like Rust is a very difficult language. No, not at all. Not at all. Believe me, once you start playing around with the advanced feature, you will fall in love with that. Particularly this very beautiful feature of macros, which actually goes into the domain of what is called as metaprogramming. Have you heard of this term, metaprogramming? Metaprogramming is where you write some piece of code that in turn generates another piece of code during and for compilation itself, not during runtime. Okay? So the compiler sees, runs those macros, generates code, compiles it. How cool is that? Okay. So such powerful features are available in it. So what you will find is that these advanced features are the ones which you will find, somewhat tricky to start with. So the first thing you have to do when you want to do any Polkadot development is to have your Rust set up properly. And again remember, when it comes to Polkadot, the preference is always for Linux and Mac OS, not Windows. Okay? Not Windows. It's not that you cannot do on Windows, but it is not preferred. The reason, why I'll tell you, because Rust internally has heavy use of the Linux, core libraries within the operating system kernel. Okay? The operating system has built-in APIs and within the kernel modules. Okay? Those are all standardized. The Rust compiler actually requires access to them. And these same functions are not available in Windows. So for Windows, you'll have to do additional installation of, build tools and all kinds of things and stuff like that. Okay? You can make it work, but perfect environment would be a Linux environment or a Mac OS environment. Right. Well, when you say Mac OS, it is basically Unix only. So it's a beautiful Unix, that's all. You know that? Mac OS is nothing but Unix only underneath. So this will be shared with you guys, don't worry about it. Okay, this will be shared with you guys and you can actually do the setup. And I will actually show you the actual web pages from where all this material has been taken up. Nothing original about it. Okay? I just copied pasted it. Okay, right. Because there's nothing to actually contribute in there. So again remember, because you have Linux, you got different distros, right? So different distributions. Now, oh, by the way, let me ask you one basic question. What is Linux? That's the ubiquitous wrong answer. Linux is only the kernel. Always remember that. This is one of the biggest mistakes we make. We say Linux is an operating system. No. Linux is only the kernel. Take the kernel and put tools on top of it and package it together, then only it becomes an operating system. So Fedora, Debian, Arch, all these are Linux based operating systems. Okay? So OS plus tools. And what are the tools? Compilers, linkers, editors, and all those things which you would need for a working, including a shell environment. After all, I need to open up some terminal window to talk to my kernel, right, and issue commands. So this basic set of tools plus Linux kernel, that's what makes an operating system. So from tomorrow onwards, no, from now onwards, whenever you say, don't say Linux operating system, okay? You should remember that it's Linux kernel. So your operating systems are these. We call them as distros. Distros mean distributions, because you see what you can do is, because you can actually customize the set of tools you want to use. So Debian has a different set of tools, Arch based has different as a set of tools and so on and so forth. And they have their own package manager. Package manager is the software installer, essentially. Okay. So Debian uses APT, Arch uses Pacman, Red Hat always uses DNF or Yum, okay, OpenSUSE uses Zipper and so on and so forth. So these are the commands you need to issue before you start setting up your development environment. Okay? And Rust installation. So for Rust installation is actually very, very simple. You need the curl command and you just issue that curl command, and what you're downloading is basically a tool called Rust Up. Okay? And this line simply downloads the Rust Up and executes it. Okay? What Rust Up does is that it downloads and installs the entire Rust toolchain. Okay? Mobile in silent place. Okay. And you could do it on Windows. So on Windows, you have, what is recommended is that instead of using on Windows directly, what you should be doing is, there is something called as Windows Subsystem for Linux, WSL. Have you heard of about that? Has anybody used it? Good. Which allows you to run a Linux as an app on your Windows machine itself. And all the Linux commands, you can use it. And in that, Ubuntu is available as an app. Okay, but then you have to go to the installation instructions. You have to basically issue a couple of commands for installing the WSL using PowerShell, and then you can actually just go to the marketplace, the Microsoft App Store, download Ubuntu and start running it just like an application. Have you tried that? You not tried that? You can try it. So if you want to practice Linux, there is no separate installation needed. Just like an application, you can install it and keep running. So what you can do is just look for WSL, okay? Windows Subsystem for Linux. Okay, I'll just say WSL install for Windows 10 or 11, whatever. Here is the link for manual installation, how to install WSL2 on Windows. Okay, go there, install WSL. Once it is enabled, okay, after that you can install your Ubuntu as an app. But again, remember, the Ubuntu that you install will not have any GUI. Okay, only terminal. Only terminal, so you have to type all the commands. So get used to it. Okay, and of course, yes, almost every Unix and Linux macOS power user, they don't use the GUI. I don't like GUI, frankly speaking. Even on my laptop also, I use only GUI for, internet and all those things. Otherwise, I do all my work in Linux only. And that too from the command prompt only. The terminal window, so-called terminal window. Well, okay, so this is WSL, so you can download that and install. And followed by that, so this is for Mac OS. For Mac OS, again, there are certain prerequisites. Your operating system version should be 10.7 line or later. Okay? If it is earlier, then Rust will not work. Okay? So I think most of the Macs would definitely have 10.7 or later. That used to be called as the mountain lion edition. Okay? 8 GB of RAM, 16 gigs is actually recommended. Okay, and this is there for almost hardware requirement is the same for Windows as well as Linux as well. And if you are running Apple Mac M1, does anybody have Mac M1? Okay, so you will have to do a special installation for additional packages, otherwise it will not run. Okay. So if you're using Apple Mac M1, then you have to do a software update. And there are the commands that you have to install. Okay, so I'll go directly to, this thing. So if you want to know more about the installation, okay, it's pretty simple. Go to rustlang.org. This is the Rust official website, rust-lang, L-A-N-G, lang.org. Okay? And here in the install link, you can get all the installation instructions as well. Okay? So in fact, from that page only, I have just copied and pasted there on the PPT. So nothing, new in it. So you can go to the install. So you see, when you click on install, what happens is it automatically detects your operating system and it says, okay, if you are using Windows, you can download the Rust up init. There's a tool there, exe. You just download it and run it. It will do the entire Rust toolchain setup for you. It's very simple. One single click download. And if you're using WSL, so here is the command at the bottom. Okay? This is all you need to do. And of course for ID, you will need, on Windows what happens is you need Visual Studio C++ build tools also. So as I mentioned, so those build tools also have to be downloaded and installed separately. Okay? So again, the link is available on the install page of Rustlang site itself. And for the WSL2 setup. You will also need the Git. How many of you use Git? Oh, good, that's good. You will need Git for Windows or Linux installed on your system, because when you go into the development of Polkadot development, you will basically be downloading or cloning the existing projects and then customizing it accordingly, according to your needs. Okay? Now this is the interesting part. Building your own blockchain using Polkadot. Okay, Substrate actually. Not Polkadot really, actually it should be Substrate framework. Okay? This is the interesting part. But again, remember, if you are running a Windows-based machine, then what I would recommend is that you should install a virtual machine and then do all the practice and all those things inside of the virtual machine. Okay? And remember, at least minimum 2 CPU cores have to be provided to the virtual machine. Minimum 2 CPU cores you will have to give to the VM itself. Okay? And lot of memory. So if you are running it under virtual machine, then in that case lot of memory is needed. Otherwise things will go run very, very, very slow. And one more thing, okay? So what we basically do is that if I want to build my own blockchain, it's actually quite simple. It's quite simple. They have given basically a template to build your own blockchain node. You can just download it and customize it. It's as simple as that. But however, what is important is you should know the nitty-gritty details as to which part does what. Okay, right. So for that, you need something called as a substrate node, which is available at this Git repository. You can clone this and then you can utilize that. Now, when you download this and and mostly you can use any development environment. So most of the times Visual Studio Code, people feel comfortable using that. It's become one of the most popular IDEs, right? If you start building it, the build process, that means compiling and building this substrate node, will take about 2.5 hours to anywhere between 3.5 hours. Okay? Because a lot of libraries need to be downloaded, compiled and installed, downloaded, compiled, installed. So first build will take close to about, on my machine I checked it out a couple of times, it takes around 2 to 2.5 hours. Okay? 2 to 2.5 hours before the prompt comes up. It keeps on downloading, installing, and not to mention in between there will always be errors also. That also you need to debug. Okay? So the first time it might seem frustrating. Sometimes things will work and things will not work. But again, remember, patience. It's very important that you need to have the patience to do that again and again till you get it all right. Okay? Now, I can show it here right away, but I won't do that. Okay? Then in that case, you will be going home tomorrow morning. Right? So we don't want to do that. Okay, so instead, what you can do is like this. So I wanted to show you something pretty interesting in here. Okay guys, please, let's look here. So even if you go to the, Rust site, there is this learn, okay. First I want to show you this, get started with Rust. You see, there is this link, read the book. This is the de facto standard and the most popular Rust resource you can find. It's called as the Rust book. It's called as the Rust book. So, if you select that, the entire Rust programming language, all the concepts and everything is described out here. Another beautiful feature, let's say I have just come here and see there. If I bring the cursor here, okay, automatically I can run this code embedded in the page itself. You can also modify this code and play around. How cool is that? Right? So no setup, nothing. You can directly start actually reading the book and then modifying the code if you want, and then you can just run it. And let me show you here. Yeah, if I come here, you'll see a crab, like red colored crab. It means that this code has got problem, it will not compile. Okay? And pretty neat. So you don't have to do any writing of the code or setup of development and nothing. Just come to this site and start playing around. I think probably many of you might have used W3 School's site, right? So just like you have embedded the editor and everything available, here also. Here along with the documentation it is there. So you can read the documentation and play around. Okay, that's the beauty of it. Use this as your primary source. Apart from this, there is also check out Rust by Example, another book, Rust by Example. Okay, this is full of example recipes. So let's say suppose about functions, and then you'll see some functions. So these are all example code available. You can just run it and play around with that. Okay. But my recommendation is first read the Rust book. Okay. So suppose you read about data types. Then you can come to the Rust by Example and see what examples are there. Then only you will have a proper sequencing of the concepts that you are reading. Okay? Right. Let me show you another beauty of this. There is also a playground. Okay? You see there? In the playground, there is an online editor, compiler, everything. So if you are too lazy to do all the install steps that I told you about, you can directly come here and do that. Okay? And you can see, so this is a simple Hello World program. Let me just increase the font size a bit because I think those of you who are at the end, I don't think you will be able to see that, right? Guys, last row. Are you able to see the code? Is it yes or no? Okay. Is this okay? So you can just run this code right away here. Just click on this. But again, internet connection is needed. See, it has run it, and here is the standard output. This is typical Rust code. Okay? Simple Rust Hello World program. Right? Fn is again a keyword for creating a function. So to create a function, you put Fn and then followed by the function name. Your entry point into your entire application would be a main function, just like C, C++, Java, C# and all. Okay? So that's your main function, and then curly braces to define the boundary of the function, and then you have the print line for hello world. But again, do you see something strange there in print line? There's an exclamation mark. So it's not a function, it's a Rust macro. Okay, it's a Rust macro. Any macro in Rust, okay, you will find it that you'll have a name followed by a exclamation mark. That means it's a macro. It is actually behaving like function, but actually what is happening? This is macro. What happens is when the compiler compiles this, what it does, hey, this is a macro, so I know what is its definition. That macro, what will happen is it will actually expand it to the code that actually needs to be run. This is not the actual code in the object file. It will actually generate the code to produce that print line, and then it will compile it. Okay, so this is the metaprogramming I was talking about. You can write your own, macros as well, and you can run it right away here. Right? How much time do you have? Enough time. Okay. Okay, any questions at this point in time, please? Yes. Oh, okay. Preprocessor, please sit down. Okay. So, macro is something that actually generates the code. Your preprocessor directive is just sitting there for, now I know you're talking about C, right? So C++ preprocessor directives are meant for essentially augmenting your code with additional code. Like for instance, when you say hash define. So what happens is the preprocessor will see you have a hash define macro, it will actually put all the instances of that, that symbol. We don't call it variable, it's a symbol. So when you say hash define n10, wherever it finds n in the entire code, it will replace it by 10. It's not generating any code. Okay. So similarly, when you say hash include, what it is doing, it's basically taking the header file, and what does header file contain? Only function signatures. It doesn't, header files don't contain anything. Have you actually seen a header file? Yes. A header file only contains function signatures. Because suppose for instance, I am using a printf function, let's assume, right? Now printf function is in which this thing library, standard library. But how does the compiler know what is the syntax of printf function? So to find the syntax, you provide the signature. The signature of a function is nothing but an indication to the compiler saying, hey, this is the syntax, this is how you have to use. Am I right? So, whatever hash includes you do, those headers are read and that code in the headers, which is nothing but basically function signatures only, they will be put up in your file so that when the rest of the code is compiled, the compiler already knows, oh, printf, its syntax is this. Okay, scanf, this is the syntax. That's how it is able to produce the error results and error messages if you make any mistake in utilizing it. So there is no code generation happening. Macro actually generates the code. When compiler sees this, it will run this macro. Macro definition is there in the library. It will run that macro, that will generate the actual piece of code which will run, and then the compiler will compile the actual generated output code. It's a different process altogether. But good question. So, yeah. Any other question, please? Guys, ask questions, yeah. Any other question? Yeah. Yes, go ahead, please. Sorry? Okay, no, it's not like that. See, please sit down. Yeah, now these are the sort of questions you should be asking yourself. See, I can build a blockchain using any programming language. It does not have to restrict. I can build a blockchain using Python also. Okay? I can build it. It's no big deal. Okay. Sorry? Oh no, that happens only first time. This is on an online environment. It has to connect to the server, get the responses, pass the entire code to the server where it will get compiled. So no. If you are doing it on the local development environment, then it is not like that. Then it runs like a jiffy. It's very fast. You are using a playground. Yes, the playgrounds are not meant to be fast. Okay. So, I can develop a blockchain using any programming language. First and foremost, you need to understand what is a blockchain. It is just a linked list. It is just a linked list. Nothing beyond that. It's a reverse pointing linked list. That's all. Generally in linked list, what happens? First node points to the second node points to the third node points to the fourth, likewise, right? Here, the linking is done through the hashes. But, okay, right, it's my team. Okay, right, but here in blockchain what happens? The second block contains the hash of the first block, third block contains the hash of the second block, likewise. So again, it's again a linked list only. There is no magic in blockchain as such if you see. Okay, it is just pure linked list, nothing beyond that. Where every node is nothing but every node contains data, and what is that data? Transactions. That's all. Finished. So it is not something very esoteric in nature. So you can use any programming language. Now Polkadot, they have gone with Rust. Why? One is that when you develop, see, one of the chief problems with blockchain is that it is inherently slow. It is inherently slow. So you need some language which actually generates code which runs fast. So what would be your option? C++. But C++ has another set of problems, and that is memory leaks and all kinds of stuff. So, the designers of Rust actually designed this to be a systems programming language where I need not bother about memory management at all. You see my point? So if it is a C program, first I will do malloc for memory allocation. Then I will use the memory. And then and at the end of the program, when I don't need the memory, I'll use the free function. If I forget to use the free function, what will happen? Memory will leak. Right? So the entire responsibility of managing the memory is put on the developer. In Rust, that is not the case. You don't have to worry about it at all. The compiler will take care of it. And there is no garbage collector as such, you know. You can do garbage collection also. Okay. So what happens is, it actually keeps clearing memory and managing memory for you in the background. You don't have to worry about that at all. So what happens? You get the best of both worlds. The speed of C++ and no headache of memory management. This is the reason Polkadot team, they went for Rust as the de facto language to use for their development purpose. Okay, any other question please? Yes. Any other question? You raised a hand, right? No, so you are just yeah. Well, let's not get into those benchmarks because those are kind of what to say. But yeah, Rust is fast. That's it. Yeah, it is being done. It is being done. In fact, now the part of the Linux kernel is being rewritten in Rust. Yes. But again, remember, whether Rust is fast or C++ is fast or C is fast, those benchmarks are kind of, you have to do your own benchmarking, because the benchmark code actually depends. Whatever code you have written, that only decides whether a program is going to run faster or slower. Okay. But yes, it's as fast as C, C++. So that's actually a good question. Why is it that we're not writing OSs? Yes, now it is being done. In fact, even Microsoft has a complete team working on Rust itself. So probably you might even see, parts of the Windows operating system being written in Rust. But more importantly, they are already thinking of, Linux kernel features into Windows natively. The day that happens, almost, all the operating systems will be at par. Because then we get what is called as POSIX compliance, which makes API development across all the platforms very easy. Because it all gets standardized. It all gets standardized. Yes? How Rust provides? Loose coupling. Oh, okay, right. Good thing, good job. You need to ask questions like this, man. Okay, so first off, how do you achieve loose coupling? You give me the answer, not with Rust. Without Rust. Loose coupling. Okay, so where did you hear the term loose coupling? Operating systems? No. Java. What do you use for loose coupling? Interfaces. Yeah, sit down. Now, okay, so that is used for loose coupling, that's absolutely right. But Rust is not an object-oriented language. It has some elements of object orientation, okay, but it is not object-oriented. So you don't have to think about, coming up with, so it does have concept of interfaces, but they are not pure interfaces as such. So you can achieve loose coupling. So we call them as, implementation blocks. These are called as implementation blocks for structures. There is no such thing as a class in Rust. Okay, there is no such thing as a class in Rust. You can think of it like, somewhere sandwiched between one step ahead of procedural, but one step below, object-oriented. So that it can take advantage of some conceptual advantages from both the ends. Okay. right? Okay, there was one more hand there, right? What was the question there? Yes. What was your question? Good afternoon. Okay. Sorry, come again please, I could not hear. Somebody's music is playing. Yeah. Hey guys, silent please. He is way back at the end of the room. Yeah. And learn to shout here. Yeah. The question is? No. Okay. Bridge is again an application which you can develop with any programming language. See, Rust is not meant for blockchain development. Rust is another programming language which can be used to do blockchain development. Please try to understand. Do not mix Rust and blockchain together. Polkadot team has selected Rust as their. You ask me a question, I am answering you, and you are talking to your neighbor. I don't know what I am supposed to do. You might not have as well asked the question, right? Don't confuse between a programming language and an application. It's just that the Polkadot team has selected Rust as the language for development, for everything in Polkadot. It has nothing to do with, don't think that to develop a blockchain I need Rust, or Rust is only meant for, blockchain development. You can develop it in any programming language. Okay. Yeah, any other question please? Any other question?
And guys, as far as the bridges are concerned, bridges are like Silva sir said, bridges are basically functional application created in blockchain to transfer assets from one blockchain to another blockchain. So we'll talk about that. So how exactly bridges function and how exactly they are implemented. So bridges can be implemented in any blockchain, any language which is supported by blockchain. You can build blockchains using Ethereum languages also, right?
Yes. Okay. So when it comes to Polkadot, the framework that we use is Substrate. Okay? So, one of the important things that you have to do is, if you want to get into Substrate, one, you need to know Rust programming. There is no other way out. Okay? So usually getting into Polkadot development takes a little more time, because if you are not well versed with Rust, you need to become, at least intermediate level of Rust you need to know. It's only then you will be able to start working with this. Okay. Now, the development environment that I was mentioning, you will have to run, if you are using Windows, you will have to run them in virtual machines and use that. However, you do have a playground here as well, which makes it a little easy for us. Okay? Right. So, first things first, go to the developer section and you have the documentation. You also have the Rust documentation. There's a marketplace, there's a playground, smart contracts, substrate. So first things first, what you need to do is go to the docs section. Very extensive and pretty good documentation in here. They've done a wonderful job. So you have this get started guide where it explains the blockchain basics and why you should use substrate, what is the architecture, followed by the hands-on, build a local blockchain. And this is the example I was talking about. And this would become your starting point, okay? So everything you need is given in here. So basically what we are trying to do is there's something called a substrate node template. What is a node? What is a node? It's just a computer, right? So a substrate node, what it does, it just runs the blockchain. That's all. So what you need to do is, you need to run the blockchain software, right? That is what this substrate node template is. So you have to compile and build it, and then you just run it, that's it. And you get a node up and running. And it is actually running a blockchain. It will actually run a blockchain on your machine. Okay? Built from scratch. Built right from scratch. So, if you want to do that, you can do that in the playground also. Let me just show you. So you can either use one single node template or you can use the front end template. So these are the only two templates available for now. So what does it contain? See, it contains a skeletal blockchain with essential capabilities including P2P networking, consensus, finality, account, transaction and pseudo governance modules. In fact, if you look at this one paragraph, it tells you everything you need for any blockchain to work. What do you need? A governance, transactions, consensus, P2P networking. These are the four basic elements you need to run any blockchain. Okay, so now let me show you. So people just look at the projection please, look at the screen. You'll have to log in there. Okay. Okay, so the playground is starting up. So it is deploying the image. So this whole thing is running in cloud. Okay? Okay, anyone trying the playground right now here? Anyone who is trying this playground right now here? Okay. Okay, so meanwhile, if you have any other questions, I'm ready to take by the time it starts up. Any questions, please? So I see there are no questions, is it? Yes? Sorry? Oh, dependency injection and all. Those are actually part of, how would I put it, frameworks. Okay, okay. Guys, stay silent. Okay, you can sit down. I think we have a new participant who has just arrived there. On 4 legs. See the most active participant, see? He is running around the room. Okay. Anyway, right. So guys, listen up. It's actually a very good question in a sense, okay? Please listen to the answer. Because these sort of questions and the kind of answers you get, you will not get it on any internet page also. Right? Okay. What's your good name? Prabhas. Thank you, Prabhas. Wow. Man. Okay. So yours is a very popular name here. The entire Telugu world knows you, isn't it? Okay, so first I'll answer your question and then I'll get back to the name thing, okay? Man, it is taking so much time. Okay, right. So, see, again, remember, guys, listen up. Do you know what Prabhas actually asked? He asked about dependency injection, right? Is there any dependency injection in Rust or not, right? Okay. So first and foremost thing you have to understand is that dependency injection. Oh, by the way, have you heard of the term design patterns? So dependency injection is actually a design pattern. Okay? Remember, dependency injection is a design pattern. You can implement a design pattern in any language as you want. Okay? So a design pattern like dependency injection is regardless of any programming language. It's like design pattern is not implemented as part of any language as a core feature. You have to add it as part of using some framework. Like for instance, on the front end, if you are using, let's say Angular or Vue, these have built-in dependency injection. So that means somebody wrote code for implementing dependency injection. Okay. So similarly in Java also you have dependency injection. Like Spring Framework provides you with dependency injection. But again remember, the Spring Framework has implemented the dependency injection. It's not Java which has dependency injection. Using Java, you are writing dependency injection, building in dependency injection and as part of the Spring Framework, and then you utilize it. You get the point? So dependency injection is not any language feature, it's a design pattern. Now as far as Rust is concerned, can you do that? Yes, you can. After all, it's a design pattern, it can be implemented in any programming language that has sufficient support. Right? It's as simple as that. The only thing is, usually what happens is we think of design patterns from an object-oriented standpoint only. Okay? But these design patterns can be implemented in a procedural fashion as well. But there will be certain restrictions in there. Okay? Very good question. I have never come across a question like this. Give him a big hand. Okay, so now that Prabhas is a famous guy, okay, and all of you know my name, right? Selvaraju, okay. So basically what happens is, actually, I am from Tamil Nadu, but we speak Telugu at home, so we are a multilingual family, okay. My kids speak 5 languages, okay, right from their childhood. But I was born and brought up in North. Okay. I was born and brought up in North, and in fact I was born during the 1971 Indo-Pak wartime and spent my childhood in Punjab. In fact, my first schooling was a Punjabi school. I speak fluent Punjabi. Okay. Then my education in Rajasthan, and finally I moved down to Tamil Nadu. The truth is, when I was studying in school and the college, so North Indians, they always find South Indian names difficult to pronounce. And mine was that case. Mine was one of that case. So, in the attendance rolls, okay, so my full name is C. Selvaraju. So they will keep on, calling out the names A, B, C, D, and then once they reach my name C, and then they'll stop. And then they will read. And then finally. So most of the times I was called Silver Raju. And still there are a lot of my classmates still today with whom I'm in touch with. They still call me Silver Raju. And guess what? The irony here is that in Tamil, Selva means gold. They devalued me to silver. Okay. In my entire student life, there was just only one professor who did not stop at my name and like this in a jiffy, okay, he just orated my name without any problem. Okay. And it was like this, say, okay, so and so, so and so, so and so, see slave Raju. And I was like, nah. Silver Raju became slave Raju. So, so from that day on, I'm very careful. I'm very careful, okay? And my elder daughter also, always has a problem with her name. So her name is Krishna. And she comes and complains, Daddy, you people have given me a male name. So she is a Krishna with a double A. Okay. So these sort of things happen. Okay. Now, the beauty is that, okay, so from that day I learned, how important name calling is. So I always ensure that, I get the name right, no matter what that person is. Okay. And I tell them very clearly, hey, my name is Selva Raju. So much so that, frankly speaking, people think that it is, Selva Raju is not one word. So in my 10th board examination, Selva and Raju are separated, they're divorced. Okay. It was Selva Raju was one family, and so in my 10th board it is Selva and then Raju separately. And in 12th board it is Selva Raju as one single person. Okay. So all sorts of things happen. And the beauty is, the government records, man, I don't know what is wrong with this. It would only take a couple of minutes to start off. Maybe the server is too busy, so that's why this is happening. Otherwise, it just deploys in just a couple of minutes. Okay, it doesn't take this much amount of time. So as I was mentioning, so one of the important things is that before you get into substrate development, guys listen up. So before you get into substrate development, you have to know Rust. Because the kind of code that you will see in substrate, okay, it will look daunting to you and really frustrating to start with if you don't know Rust. But if you know Rust, then in that case it's not a big deal. Therefore, practice some amount of Rust, go to an intermediate level, and then start working with that. So let us just see the code in there. So I'll just go and play the code there. Oh, I'm sorry, not the Rust docs. So build a local blockchain. Here is the substrate node template. Now this is the GitHub repository there. Okay. This is your GitHub repository for the substrate node template. Again, remember, if you look at the code, okay, first time if you look at the code without knowing Rust, you'll find, as I mentioned, you'll find it very daunting. Let me just show you here. So let's say I have the palettes. Go to the SRC. Oh, this is benchmarking. Okay, leave it. Runtime. SRC. Guys, please. Okay, now see there. In this, all the code that actually is needed by a node to run. Okay? And all these files will have .rs extension. The rest files have rs extension. Okay? Now let me just show you some code in here. So the entry point is always in the main.rs file. All other code goes in the lib.rs file. Okay? And additional files. Okay, so let me just show you the main Rust file. Now look at this code. Last row, are you able to see this? Yes or no? Is that okay? Why are you singing? Yes, sir. No, sir. Okay, right. Now, the reason I opened this file, okay, is just to show you one simple file in here. Now, just if you take a look at this, is it making any sense? And your substrate code will be full of such these sort of symbols. You'll see hash followed by, exclamation symbol, and then hash, and then followed by this square bracket, and so on and so forth. But actually, right now it will seem very difficult simply because you don't know Rust, that's all. If you know Rust, okay, what does, so basically, now you see, let me explain. It's actually quite simple. This is again, this part that you see here is called as the annotation. Annotation actually brings, so these are also called as decorators, which bring in additional functionality into any existing code. Okay? So this is the Rust annotation. It says warn missing docs. So any missing documentation, it will give you a warning. The compiler will not compile the file, it will give you a warning. So we are setting this up. So we are setting the warning log level. That's all. Okay? Then it says mod chain underscore spec. It means there is some file called chain underscore spec.rs file. You have to include that. That's all. Huh.
Yeah, but
Sir.
వస్తుందా అక్కడ Hi guys, so yeah, technical issues are kind of fun here. So how many of you, it's been a very long learning process today, so how many of you are really enjoying it? Wow, cool. So what we are going to do is, we are collecting some video bites. Some of your friends have already given their video bites yesterday. So today we need 5 to 10 people who can give us video bites now.
Yeah, Shweta, these two didn't raise their hands, so they are not enjoying.
Who?
These two girls did not raise their hands.
Okay, these two
friend.
girls are coming
Yeah.
with me now. 3. Girl, stand up. Stand up. So, who else? Okay, stand up, stand up. I need 10 people now. 4, 5, 6.
Guys, please, please.
Enough, thank you guys, please.
Maintain the decorum, please.
1, 2, 3, 4, 5, 6, 7, 8. Okay.
Done?
Can I take them out?
Yeah, sure.
Guys, please come outside with me.
Okay, guys. Now you can stay put. Okay. So, if you are coming to Rust for the first time, if you know Rust, it's actually pretty simple. You are just including services.rs file, benchmarking file. So those are all there in the current directory itself. Mod means include a module. Include a module, that's all there is to it. And then if you see the main function is just a one-liner. It's just a one-liner. And what it does, so basically how we are defining it is that the function main and then this is the return. So if you are going to return something, you put an arrow. And then what type you are going to return. So there is a built-in library type sc_cli followed by result. Don't worry about this. So this is some data type. Okay. And here inside the code we are just running command and then followed by run. Finished. Now where things get a little complicated is okay when you are doing a lot of configurations in it. Okay. So let me just show you. So as I told you, right, so these are all mods. See, command rs, librs, pain rs, rpc, services, chain spec, benchmarking. So if you go to benchmarking, let's say, you are defining this as a module. Okay. So a module, if it has any dependency on other libraries, we use the use statement. Use followed by whatever library you want to use. Okay. Right? I'm not going to give you details of Rust here, okay, because you have not yet learned, but again remember, all I want to tell you is that it's not difficult. It's actually quite easy. Once you know Rust, it becomes pretty straightforward. Okay. So let me just show you. So you will find, a lot of code written like this. This is where when you start working first time, you'll find it a little difficult. But again, remember, the beauty of this code that has been provided is full of documentation, full of comments. Okay, a lot of comments are there. So go through this, look into the comments and see what is actually happening and what is actually going on in there. So let me just show you an example of it. So this is the runtime. So you'll see some macros for configuring the attributes. Okay. There is some recursion limit that has been set up. What configuration feature you want. What is that you want to include. Any inclusion of the external files. Right. Then palette grandpa. What is the configuration in there. So likewise. So if you see here, actually the code is quite straightforward. It's not difficult at all. The only thing is, once you know Rust, look into the code for a couple of times and you'll actually feel very comfortable. It's not difficult. The only thing is, the better you are at Rust, okay, the easier it will be for you to make use of this. But that doesn't stop you from actually using this without knowing anything also. Because if you go to the Substrate documentation site, they have given how you can add a new palette, how you can customize a palette and all those things. Just go to the right line number and make the changes that they mentioned and you'll be good to go. But that is not the right approach. Learn Rust so that you know exactly what is going on in there whenever you're making changes or adding some palette code and stuff like that, okay? Right. Anyway, you will have second module on the online sessions wherein you will learn all of this as part of your training, okay? So you will see a lot of code like this: pub use, frame system, palette balances, palette timestamp, and so on and so forth. And if you see here, this is where all the documentation is there. See, opaque types. These are used by CLI to instantiate machinery that don't need to know the specifics of the runtime, so on and so forth. So a lot of comments are there, which make it quite easy for you to get into the nitty-gritty details of what is exactly going on in the framework code. Okay? So you won't find it much difficult. But of course, it's not like a cakewalk as well. So some amount of time you have to spend in order to be able to, comfortably walk through all of this. And guess what? You can build your own palettes. So you can go to various other projects who have actually built the palettes. And you can see their source code, you will understand how the palette is built. So start from a simple palette. What is the minimum required? So what exactly is a palette? Palette is nothing but a self-contained module which can be added as a feature into your blockchain. That's what really a palette is. It's a self-contained module that can be added to your blockchain to enhance the blockchain with certain additional features which are being provided by that palette. That's all there is to it. No rocket science behind it. No rocket science behind it. So it's actually quite simple to use. Of course, first time whenever you start, things will seem difficult, but it's not that you cannot do it at all. So it is not impossible. It's just that you will have to spend some time. The level of difficulty will come down automatically. Patience and persistence is what is actually important for you to be able to contribute to this. And you know the beauty, once you've gotten comfortable and you have some project idea, you can propose this in the Parity's website and you can even get grants. You will be given money. So you can go there and check out what kind of projects have been proposed by other people. And if you see that you can come up with some innovative idea, which is always possible. And then you propose that idea, and if they like your proposal, they'll give you a grant. They'll give you a grant. And a lot of people have actually taken grants from the Polkadot ecosystem. So you can also do the same. Okay? So we will leave this playground running for some time. Let's see if it loads up. If it loads up, no, it's taking time. Happens. So you would have been in a position to actually see the local blockchain running. Anyway, so we'll leave it and we'll try it tomorrow, okay? Wherein I can show you how to run the blockchain, local blockchain inside of the playground and check what is going on inside the blockchain from the UI. So They've already provided with a basic UI which we can utilize, called as the Polkadot.js UI. Okay? Right, so that's it from my side for now. Okay, I'll talk to you guys later. Okay? Right, see you guys. Bye-bye.
Thank you so much, Selva sir. Yeah, so guys, how many of you are not yet on Discord? Okay, try using the laptop, it won't require the OTP. Anyone else? Okay, so on Discord, I have put up a Google form in the, you might have already seen now, IBC Alt Hack Vizag. In that there is a channel called Idea List. So over there, I have already put a form, Google form. As you know, day before yesterday, Praveen sir had requested, not day before yesterday, on Saturday, had said that we will revisit the ideas that are created by you. So he suggested me that I give you one more day to come up with the ideas. So there's a list of 20 ideas that you all should come up individually, right? So open that form. Did anybody see it? Okay, so just check that form and start, give all the information required and then submit your ideas that you would want to work upon or build. And secondly, there's another thing. How many of you have a GitHub account? Oh, very nice, very nice. All the students who don't have GitHub account, it's okay, raise your hand. No, if you, yeah, okay. Can you guys create a GitHub account? Yeah, okay, because in the form, you also have that option. I mean, you also have a question where you have to put up your GitHub account link, right? And it's a compulsory column. I mean, it's a mandatory column. So you'll have to create the GitHub account and then enter your GitHub account link over there, right? So two things are very important, Discord and GitHub. All these forms are all temporary, but these two places will be permanent communication with you guys, of IBC Media with you guys, right? So create the GitHub account, then enter the link, and then work upon all the ideas and whatever you have already come up with, enter those ideas and work on the same. Make sure your friends who might not be here also know about the same thing, right? Now I would request Praveen sir to come and give a summary and some other important things that he would like to discuss with you.
Okay, so how was the day today? I didn't get that. So was it okay? So can anybody stand up and tell me what have you learned in the whole day? Who wants to explain the whole day? Anybody? Who wants to explain what all have you gone through the whole day? Anyone? No takers? Yeah, tell me. I want to see who is that courageous person who comes and forwards and talk about it. Not a single hand? You want to talk? I ask you. Janvi, you want to talk? Give her the microphone.
So that's a very scary thing to ask. I mean, thoda settle down, we have to say just give it a shot.
No, I think that's fine. I know they have learned a lot.
Absolutely.
Yeah, go ahead, Janvi.
We got to learn about Polkadot and Rust is a programming language and Substrate is a framework that we use for building blockchains, and Polkadot helps in building and connecting different blockchain networks, and it provides scalability, and we also learned about tokens and difference between tokens and currencies.
Give her a big round of applause. Now, why was this a difficult thing? Nobody raised hand, or you are busy in something else? GitHub. So guys, I think I agree with Janvi that this was an important day. You were exposed to various things which are important, of course, in blockchain in general. You also must have got a deep perspective of Polkadot ecosystem, right? How does Polkadot work? How is the infrastructure of Polkadot, right? Can anybody explain the infrastructure of Polkadot? Yeah? Yeah, I think I would love to have somebody raise his or her hand yourself, not me forcing. Let me see who is that person today. And that person will get special mentoring from Selva sir. I am committing on your behalf. Sure. Yeah. Who is that person? Tell me. You are not required to be perfect. One person. Am I not seeing the hands, or the hands are not there raised? I am trying to find where is that hand. Come on, guys. One person. Who is that person? Deepak, you may want to go inside.
Yeah, but I also want to, I'm seeing a lot of students on the laptop. Guys, the form is open till tomorrow, right? If you are not attentive here, you'll miss this just for a form. It's just a form. There's no rocket
science. Okay, you can do that later also.
Yeah,
form you can do later also. So now I should see many hands raised. What happened? Very good. Say your name. First of all, give him a round of applause. Please say your name and then explain the infrastructure.
Yeah, my name is MVS Padasarthi. I am from Sai Ganpati Mechanical. Okay, the infrastructure of a Polkadot. The question is, the infrastructure of a Polkadot is the outline of a Polkadot is in a parachain.
Okay.
The media, there is a silver ring. It is called as a relay chain. Okay. After that, there is a media blocks, validators. Okay. After that, validators. After that, we have collators. They are the parts of 4 types: validator, collators, nominators, and nodes, and relay chain also.
That's it.
Okay.
That's it. Now, so let me ask one thing to all of you. It is very easy. Yeah, sit down, Mr. MVS Parthasarthi.
Thank you, sir.
Yeah. Good job. Keep this in mind in your life. Always have audacity, courage to jump into water, not real water. Don't say that Praveen sir told me to jump into water. In professional context, I am saying. Don't be scared. Remove those inhibitions. Are you guys getting it? You should not have inhibitions. If you are having inhibitions, then your growth will become 20-degree angle. You know what is the difference between 20-degree and 75-degree? What angle do you really want? Learning an angle? 10-degree or 80-degree? 80? Which angle do you prefer? 10-degree? 80? 90? Yeah? Then you have to have that courage to explain yourself. And nobody is judging you, by the way, here. Now let me ask another question and then see responses here. Okay? I am not generally going to leave you like that. You know that, right? What is the difference between relay chain and parachain? Let me see how many hands are there now.
Relay chain and parachain. Come on. MVS Parasarthi has already explained. Don't tell me the color is yellow and this color is blue. No, I will not accept that. Do you guys understand that, or you, Selva sir has explained, in much detail. So let's try to summarize the day. So Polkadot blockchain is a blockchain which enables you to create your own blockchain. Listen to me very carefully. It enables you to create your own blockchain. And these blockchains are called parachains. Right? Why is it so important? Why could you not have done? There are several other protocols also, blockchains also, which allows you to do that. There are, projects. There is something called Cosmos. There is something called, Polygon. They have several, tools which allows you. See, one thing is that you have to understand. Creating a blockchain like Selva Saab was mentioning, creating a blockchain is very, very extensive process. What is that process? Can somebody explain to me? And guys, please open yourself up here. Don't close, don't hold yourself back. If you are holding yourself back, your consumption will be very, very limited. Talk nonsense, that is also fine, but within the limit for sure. Right? So creating these blockchains is very, very difficult. You have to think of consensus mechanism. How are you going to, make your, I asked one question yesterday, day before. Proof of work and proof of stake, they are primarily used for doing what? Securing your network, right? So if you are creating a blockchain, you need to have mechanism to secure it. You need to have mechanisms to, for example, tokenization. You need to have several other things that you have to go and figure out. You will have to go and arrange your own validator nodes. Right? All these things, you will have to write all those logic. Not so easy. So what people said, okay, let's create this framework in which, like Mr. Selva was mentioning earlier, there are already defined code, which is called, in substrate framework, what is that called? No. Pallets. These pallets are already defined, done, with some standard assumptions that you will follow this. Are you guys getting it? You should follow this if you really want. So, interesting thing. You can go and pick up these pallets and create your blockchain in half an hour. I was watching one video which was done by Mr. Gavin Wood himself in one of the meetups, where he opens a Mac machine laptop live, he chooses some pallets and he creates a blockchain in half an hour or 1 hour. That is the beauty. That's what this substrate framework gives you. But what also is there, that if you really want to go and tweak things, you say, no, my validation process will be little different. Go and tweak on top of that. You can do that. But you already have 99%, go and make change 1%, 2%, 5%. Understand that point? Now, this is the framework. Now, in the center is the relay chain. Center is the, what does relay chain do? Relay chain is the, is the medium through which all the parachains interact with each other. And there was somebody asked a question earlier, why do different blockchains need to interact? Who asked that question? Who asked that question? Somebody asked that question. You asked that question? These people were asked the question. Okay, now it's a very interesting thing. All different blockchains are for some specific purpose. You may need to go and hit some other chain to do something which functionality you don't have. You don't go and build everything, right? So there only, you as a parachain, you interact with other parachains through these guys. Now this is a very, very powerful, I am talking about, see, one of the problems that blockchain industry has, still having, is interoperability. What really has happened in last so many years, that all these blockchains have come up in isolation. No blockchain ideally could talk to each other without any doing lot of, manipulation, or not manipulation, but mechanism. And that's where somebody asked about bridge. Who asked that question? Bridge. Somebody asked that question. Bridges, right? So the bridges are basically functionalities. Now there are different types of bridges. But bridges are mechanism in which you create one smart contract, okay, and then you lock some, say for example, if you have to take one asset from one blockchain to another blockchain, right? Now if you put Bitcoin in Ethereum network will not understand Bitcoin, right? Because Bitcoin is built on some other fundamentals, right? Ethereum is a different environment altogether. How do you do that? So what you will say, that if you are a reliable person, then you will go and lock your Bitcoin in one smart contract. Smart contracts can hold value. Smart contract can hold assets. Okay, and we'll talk about all this, and don't worry if you don't understand completely. But you will lock the Bitcoin here somewhere, and release equivalent amount of Ethereum compatible currency or token. Now that can be in the Ethereum, that can work, correct? Are you guys tired right now? I don't see any response. Should I not continue here? Yes or no? No, again I didn't get the answer. So should I, okay, raise your hand if you want me to continue. Only few people. Raise your hand if you want me to stop. Now what do I read from the middle one? Huh? Sorry? Tri-state. So don't be in the plasma state, right? Be in the one of the three solid states, liquid states or gas states. Okay, I'll not make it long. So, but my only purpose of talking to you right now was to consolidate everything that you have been doing since the morning. It's important thing for you to understand that, okay? We'll talk about bridges later, don't worry about it. But one thing we have to understand, that what Polkadot brings on table, and of course we will have, after this, after your on-ground is done, we have our program called Continuous Education Program, CEP, in which I would like you all of you to enroll, and we will be getting you through complete deeper exercise of coding in Rust, which Mr. Selva will be handling, and you will be getting a lot of hands-on experience in coding also there. Okay, so we'll get you more details on that. But two things I want to talk about right now. One is the idea. How many people have got some ideas, who have written down the ideas? One hand, 2, 3, 4, 5, 6, 7, 8, 9, only 9 out of 300? That's a little less, right? So I had given the target of Monday morning, correct? So how many ideas have you got? Janvi, you raise your hand. What is your number of ideas? How many? Around 10. Who is, okay, who else? Who else had raised their hand? Raise it again. Yeah, how many ideas you? 3. Good, okay. How about you? 3. 4. How about you? 5. How about you? 10. This side, left side? 10. Okay, anybody here? Yes. 10. How many of you? 9. How many you? 1. Okay, good. So guys, how do you get the ideas? So one way, I think Deepak has already given also the link of the ideas which people have tried, right? How many of you have looked at that link? How many of you have looked at the link that Deepak provided, which has the ideas from the previous batch? 1. Nobody else? 2. Do that first. Okay. Can I expect 20 ideas from each one of you by tomorrow morning? Yeah? Tell me yes or no. Raise your hand if you are okay getting with 20 ideas tomorrow morning. Raise your hand. Okay? Please, feel free.
Yeah,
guys who have not seen the ideas that were collated in our previous Alt Hack, so I have put the link in the idea list, okay? At the same time, the Google form that you have, it also has the link for the same in the description section. If you open the form, in the description, there is the link as well. So it's very easy. If you don't want to do that also, you can just go to the website and check it out. But the best way is either check the Discord or just open the Google form. In the description, you'll find it. Go and take references.
Yeah. So I want you guys to come up with ideas. Now, how do you get ideas? How do you get ideas? And I think I'll tell you, this is the toughest thing to do. When you start writing about ideas, no idea will come. Right? Have you noticed it? You sit down and say, I will get some ideas, then your brain will become blank. Has it happened with anybody? Yes, sir. Yeah, it happens with me also. So what I typically do when I go for walking, I'll keep a small, diary with me. And thoughts keep coming. When the thoughts come, then only at that time only you can write. Now, nowadays it is a gadget time, so you may not want to keep diary, but you can put in your mobile or somewhere, right? But ideas keep flashing. Okay, capture that point only, because if you lose that, then it is gone. Okay, but now, what I'm talking about here is a systematic method of getting ideas. How do you do that? So, first of all, you have to understand the space. What space you are talking about. If you are talking about finance, if you are talking about agriculture, there are so many ideas. Many things could be done. Insurance, there are many ideas. You have to look at the surrounding, what problems you are facing. Okay, and then once you and then you see what could be done, and then you go and look at what exactly is available there. It may happen, and am I expecting you to come up with an idea like Swiggy or Zomato immediately? It will not happen. It doesn't happen just like that. It will take time. You will have to go through iteration process. But if you don't start, then it will never happen. That also I am telling you. So you have to think, maybe, but don't copy others' ideas. Try to be as unique as possible. Make sense? No? What happened? Too many classes today, or people are not feeling energetic, or what? Lot of information. What happened? Why so quiet? Guys, make noise. Somehow I don't like, I hate noise, the silent classes. No. Who can shout at the, topmost voice? Sorry? Okay. Okay. So I think do this, okay? The point is that, look, I have told this in day one or someday, that nothing worthwhile, nothing important comes to you easily. If it was you, did you hear Urban? What he said? What did he say? He said that he is looking for people with skill. And of course, you also have heard Abhishek, what are the prospects and possibilities here, correct? Now the point I am only trying to say that, do you have in it you to make it big? If you have in it to make it big, you will make it big. But if you are laid back, if you are shying from raising your hand, I am hinting. But if you are very good in clapping, somebody else is answering then. Don't be follower. Be a leader. Do you like, or am I scolding you? You need to have that. And I always say that, don't aim for anything. Do not aim for anything where you need to think, okay, let's get for this only. No. This is the time for you to dream, and dream as big as possible. I always love our earlier president, Kalam Saab. He says, your eyes should tell your dream. Do you dream? Do you have a dream? How many of you have heard, who said this? Abraham Lincoln, right? Who said, do you have a dream? Martin Luther. He said this, do you have a dream? And I'm asking you these questions right now. Do you have a dream? Do you have a dream? And that is very, very important. That is very important. Without a dream, you will not go anywhere. And I can write you on a bond paper. Okay? So with all these things, what I will also request you, that we want you to form a team of 3 people. We want you to form a team of 3 people who will work together. Okay? The idea here is that I want you guys to select 3 people who would love to work together, and maybe, you know, these 3 people tomorrow could become another Polkadot company. Why is it not possible? Next Polkadot comes from here. Gayatri Vidya Parishad venue. Next Polygon can come from here. Guys, so what I was saying, what Deepak was telling me just now, that I mean, people are still so much energetic, so let's have this session continue for next 2 hours. Yes? And people are saying yes, they are ready. Okay. So now, guys, give me 2 minutes. So basically what I was saying that all these things I am telling you, I am not giving you gyan. Believe me. I am not giving you gyan. I used to be a student like you 26 years ago. 26 years ago, I was also, how many of you know the branch production engineering? Production engineering, do you know the branch? I am from production engineering. And by the way, you know, I was also first and second topper of my branch all the time. Always. Yeah. I mean, I don't know, but yeah. So I always used to be either a gold medalist or silver medalist in my branch, always. And not only that, I mean, from there onwards till, I would say now, wherever I have worked, you know, I have always, I share my story with your beloved friend Deepak Singh, that if there are 2 choices, give me guys 2 minutes if you, thoda sa sun lo hai. So, if I have 2 choices, I'll always choose the more difficult one. No, believe me, and I think I'm not saying that because I'm doing because I'm great, no. Because if you are choosing something which is less valuable, it will come to you with less effort. But what you will get also, you will not be proud of that. Isn't it? Am I wrong? Yes. So the point is that, now guys, hold on. So you are in this room, I don't know, you know, there would be some stars, some aligned somewhere, and believe me, not everybody, like Abhishek was saying, not everybody gets this opportunity. I don't know, some stars may have aligned somewhere, some stars for you may have aligned somewhere where you have landed in this room. I'm not sure why and how and, you know, where. It has happened, believe me. Now the responsibility comes to you, that are you leveraging this or are you just letting it go? And I'm not joking, I'm telling you. I work with, I would have spoken to almost, you know, the senior most people from the blockchain industry from across the globe. And what I always see that, you know, people who are there right now, it is not that they are exceptionally or they are marginally different from what you are here or what we are here. No, it is not. The question is, are you willing to put this next 1 year in a sustained way? In a sustained way to make it big. And I want you to do that. Then only whatever effort I am putting in here is worth, isn't it? Otherwise, all the effort that Deepak is putting, Selva sir is putting, I am putting, Abhishek is putting, the whole team is putting. If this is just a session which happens here, you also clap, I also clap, you also feel happy, I also feel happy, you also go and eat, what is that called? Mysuru vada, right? And I also eat my masala dosa, that is done. Seriously. Can you take this opportunity to make yourself big? If you can, if you are ready, the whole world will be at your feet. Believe me, I was attending one conference in Bangalore last week. It's called the Polygon Connect. And I happened to see the founder of Polygon. His name is Sandeep Nailwal, one of the founders. And those guys met in one of the meetups like this. The founders met two people. They discussed, they liked each other. And they created Polygon. Why Polygon? Because Ethereum 2 was having the scalability issue. Do you guys remember or forgot everything? Complete plain slate? No, not like that, right? Ethereum was struggling with scalability issue. They came up with the idea. They did that. And believe me, we will talk again. So we still have 4 more days, Deepak, right? So we will talk about several things that I want to give you perspectives. How exactly different applications which are on Ethereum, how are they being transported to other chains? How are they going into other chains? If they go into layer 1 other chains, are they going to layer 2 chains? Guys, is there something more important to talk? Guys? So if these applications go to other chains, what happens to the liquidity? What is liquidity? Liquidity is, somebody was asking me, what is liquidity? Liquidity is nothing but the value, the token that you have on one platform. Now, if you have liquidity on Ethereum and you go to other application, other chain, then liquidity is fragmented, right? How do you connect these liquidities? Now, it is very, very interesting problem. It is a technology, it is finance, right? It is community, it is management. What excites you? Not everybody needs to be a developer. That also is true. But go and find out your partner, who could be your next partner, two people. Everybody has to find 2 people. If 2 are together already, you have to find 3rd person. Can you become the next Polkadot, or can you become the next successful chain? Think of it. And I think, when are we doing that, Deepak? A team formation? Tomorrow, day after, sometime tomorrow. Let's do that. So I want you guys to think. And one thing is important, that if you find somebody who is very, very talented, who should be a part of your founding team is outside this room, don't hesitate to bring that person also. Invite them. Because you are going through a journey, let them also experience this journey and make a part of this team. Understood? So overall, was the day gave you some learning experience? Yeah. So did you learn something new today? Let me ask that question. Yeah. Are you happy with what you learned today? Yes, do you really want to learn more? Yes, yeah. Are you willing to put in effort yourself? Yes, now this voice little became less. Okay, let me ask this question. I think you may not have heard the question properly. Are you willing to put in effort to make it big? Yes. Yeah, this should have been the level, decibel level. You know what is decibel level? Yeah? Yes. And don't just say this. Don't just say this. Believe in this. Believe in this. Right? And I am always happy to help you with anything that I can from my resources. Right? IBC Media is there to provide you internships in IBC Media first, where we will kind of handhold you with various things. And then once you are ready, we will position you. Somebody was asking me, yes, why not? We can provide you opportunities, internship opportunities in the biggest of the companies. But for that, you have to be ready first.
And that's what we are doing right now. I don't want you to go and ask a very big blockchain company what is proof of work and what is proof of stake. No, you should be master in all these things. Understood? So I think, what else, Deepak? Yeah, and one last point is that if you are not being able to figure out who should be your team member, don't worry, Deepak is here to help you. Yeah, Deepak will help you form a team so that you can proceed here. So tomorrow morning, 20 ideas per person, I will personally come and ask and check. Okay? Deepak, all from my side.
So, in summary of what Praveen sir has said, I mean, I got too busy, I started dreaming. So, two very crucial things. One is that you have to form a team. The team we allow teams of three people. So figure it out. By tomorrow, try to, we will be working on team formation, so you should have those names. Keep it ready with you, have the people with you over here. In case you want to invite somebody who's also, your colleague or in the college or in your school, wherever they may be, you can invite them, not for the fun. I mean, I know it's a lot of fun, but to work on them, because you'll be working for a certain period of time, because there is CEP as well, which will be led by Selva sir here. So you guys have to work together. And one small suggestion, when you choose the team member, it's not about who your best friend is, right? It's not supposed to be like, this guy is my best friend, so I'll make him in the team. This girl is my best friend, so I'll get them in the team. It's just about who you think you'll rally along, like what your strengths are and your weaknesses. So similarly, somebody else's strength would be, they should rally with your strength. So front end, back end, or who'll manage the program and things like that. So keep all those things in mind. Make sure that your team members are able to do that. Try to the best of your capability. I mean, nothing is written in, nothing is final here. We'll work upon with you, with your team members, and figure out how best we can come up with that. Second thing is the ideas that he had spoken about. By tomorrow, you have to come up with 20 ideas, right? The form has already been shared. The reference link has also been shared in the same. The reference link as in the ideas that were previously worked upon by different students. Try to be unique, take references, but try to come up with your own original ideas. Third thing is that, not with respect to what Praveen sir said, but the attendance. We will be tracking some attendances, so next time you see your friends who might not have been here, let them know that we will be taking the attendance at the end as well. And thirdly, sir, I have a dream point. So basically, Mr. Martin Luther King, I have a dream, something in line with to see that the nation come together and value the significance of its entire creed, something like that. And similarly of Kalam, there is, I will fly. I am not meant for crawling. I have wings, I will fly. I will fly, I will fly. That's a lovely poem, you should definitely check it out. I want to thank Selva sir once again. I want to thank Praveen sir once again. And if you have any questions, you can obviously come and reach out to them for the same. And obviously Abhishek sir is not here, he'll be here with us soon. Ali sir is also not here, he'll be here with us soon. Also, it's his birthday. So let's, thank you for that. Let's catch up again tomorrow. Make sure that whatever things that are pending, you work on the same. And if there's any doubt, you can put it on Discord. Okay? Thank you guys. Have a nice day.